workshop. So first of all, good morning, everyone. It's a pleasure to receive you here for this second workshop to show you how the BIOMAT consortium is trying to working with SMEs, specifically in the topic of the foams, of the biofoams. I will be short because we are running. So basically, the idea of this workshop is to let the SMEs that are participating and also our colleagues that are assisting via Facebook and also YouTube to make them know about the project itself, about the opportunities this project have for them. How they can benefit from the materials and from the pilot lines that we are developing during this 4-year project. So I really hope this workshop is very useful for us, for you, and for us as well. But just one additional work to the partners that just accept, I would say, a last-minute invitation to present their company and the work they are doing in part of this work is being done in the thematic of BIOMAT. So thank you very much for joining us today. Regarding questions for the persons that are here today and also the ones that are basically assisting in a virtual way, we will ask you to write it in the chat. Here we'll try to manage them. We have a very tight agenda today. We have a lot of presentations, which is good, but at the same time, it can delay a bit the end of the workshop. So we will try to reply to all of them. If not during the workshop, we will for sure collect them and we will reply to you via email. So please have also your email to the answers to the questions that you are putting in the chat. So without no more words, I would say that we can start. So I would invite Juliana from Senti to give you an overview about the project itself.
Hello, good morning. Is it working? Okay, thank you. Hi, everyone. Good morning. Please be very welcome. As Antonio presented, my name is Juliana Oliveira. I come from Senti, the Center for Nanotechnology and Smart Materials, here in Famalicão, our next door neighbor to where you are now. I come here today in representation of BIOMAT's coordination team. And the goal today is to give you a brief introduction, a brief presentation, particularly to the ones that are not familiarized with BIOMAT, a brief introduction to our project and our OITB. So as you may know, more than 3/4 of the global consumption of polyurethane foams are in the, polyurethane products are in the form of soft and rigid foams that are used for bedding, furniture, building, and construction. The PUR foam market is continuously growing and is projected to reach close to $80 billion USD by the end of this year. However, most polyurethane foams, as you know, are petroleum-based and usually lack very important functionalities, such as flame retardancy, chemical resistant, etc., just to mention a few. And it is precisely in this context that BIOMAT project came into being. The goal is to establish an open innovation testbed. We'll go into a bit more detail into what an open innovation testbed is further on in this presentation. With the goal to provide services to a wide range of European companies with the specific goal to accelerate and facilitate the uptake of innovation and nano-enabled products within the polyurethane sector. The goal here is to reinforce and emphasize sustainability, circularity, and renewable resources for the top 5 markets that use these type of products, namely building, construction, automotive, furniture, and bedding. So BIOMAT is an European project. Our consortium is built of 26 partners that come all the way across Europe. And it is a very polyvalent consortium. We have SMEs, LEs, universities, research center, and even a standardization body. So the main idea behind BIOMAT is to explore sustainable alternatives to the production of foam products by taking broadly available low-value residues from agriculture and forest sources, and to then extract compounds of interest, such as silica, lignin, cellulose nanocrystals, and vegetable oils, and then use them to produce nano-enabled biocomponents and materials, such as prepregs, composites, foams, and adhesives that are then incorporated into new value-added products, such as sandwich panels, insulation aerogels, seat cushions, sofas, mattresses, etc. Last but not least, and reinforcing circularity and sustainability, these new bio-based products have the potential to then be reused through sustainable recycling processes. So I was talking previously about open innovation testbed. So it's a relatively new concept. Some of you might not be familiarized with it. So according to the European Commission, an open innovation testbed is a group of entities that comes together to provide access to physical facilities, capabilities, technology, services that are required to the development, testing, and upscaling of nanotechnology in advanced industrial environments. So the objective here is to bring technologies closer to the customer and the producers, with the second goal to advance the validation from lower scales, laboratory scales at lower tech TRLs to larger TRLs in industrial environments. Two characteristics that are associated with these types of OITBs is open access, which means that any interested user can have easier access to facilities, capabilities, and service that would be otherwise not so easy to reach at fair conditions, pricing, and in a transparent way with regards to security, safety, and very importantly, intellectual property rights. This type of OITB is open to any user. Any user can be an individual, a team, a company, a research center. It can be also public or from a private sector. So after all this, what does BIOMAT have to offer? So here you can see all the services and technologies that are available to customers through our OITB. As you can see, it's a very polyvalent catalog of services, and the goal is to provide support in all aspects of product development, from lab scale onto pilot scale, and even when possible, up to industrial scale. The idea is to be able to cover the entire polyurethane value chain, from the most basic materials and components up to all of the functional nanofillers, and then all the way up to the final products for the 5 target markets that we've been discussing. So as you can see here, the services are mainly divided into 2 main categories. So we have technology transfer services, and we have horizontal services. In what comes to the technical part of the services, BIOMAT has 12 pilot lines that are dedicated to pilot scale production of nano-enabled bio-based products and components towards the polyurethane materials. And they are divided into 5 major groups that cover the entire value chain. You will hear a lot more detail into each of these 12 pilot lines as we go throughout the workshop. When it comes to the more business support horizontal services, the idea is to provide support again in any aspect of your business with horizontal services such as products characterization, the implementation of DTP tools and inline monitoring, etc. and etc. Again, you will hear more detail of all of these services as we go throughout the workshop. But how can an SME or any other user have access to these free of charge services? I'll now pass the word on to my colleague, Barbara. She is a representative from CTV, which is BIOMAT's SEP. So, Barbara.
Hi, everyone. My name is Barbara, and I work as the BIOMAT SEP manager. The BIOMAT-TB will be operated via a single entry point, the SEP. The SEP is CTV for our project. CTV is an already established company here in Portugal that works as a certification body, and it has a wide experience in managing portfolio of customers and of service providers. Within the OITB, we will be the common point of contact between the clients and the service providers and allow the open access to the wide range of physical facilities and to the technical and horizontal services at fair conditions and competitive prices. Right now, our open tender is open and our first call is launched and receiving applications until March 31st. This open tender will be a kind of a beta test of our OITB, where we will be providing the services free of charge. So, very simply, the interested customers can apply to our open calls that will be launched from January of 2023. To that, for that, they will have to go to our SEP web-based platform, register their company, and fill out an application form. That application form is important for us to evaluate if the service you request is feasible or not. After the open calls are closed, we will move on to the customer evaluation phase, where we will do an internal evaluation to decide on the feasibility of the service. The selected customers will be able to receive the services free of charge. The next step, after the customers are selected, they will have to sign an agreement with the SEP regarding the details of the service to be provided, and the service provider will be informed to start executing the service. We want the results to be delivered to customers between 3 to 6 months, but that will depend on the course, the type, and the requirements of the service, as well as the current global situation that is kind of sensitive right now. With the open tender, we aim to do 2 major things: to provide the services free of charge by running assessments to our customers that are recruited through the open calls, and practice the use of most of our 12 pilot lines and horizontal services. We will also be giving mentoring for funds raising to 2 of the customers that are recruited through the open tender. That mentoring will be for public and private funds and will go for 12 to 18 months. So if you have any interest, please apply to our open calls to receive our services. Thank you very much.
So, thank you very much, Juliana and Barbara. So now let's test the connection to Teams. We are now starting the presentations from the SMEs that were invited to be here today. The first one, it's not an SME, it's a cluster which works in the sustainable habitat, so it's kind of connected to the construction sector. And well, I will pass the floor or the display to Professor Vítor Ferreira.
Well, should I
Yes.
intervention now?
Yes, you can talk. Everyone is looking at you, so please feel free to,
Okay.
to do it. Thank you very much.
Thank you. You are hearing me well then. Well, first of all, thank you very much for the invitation. It's very important for us to be here. As you have said, I am representing one of Portuguese clusters, the cluster Sustainable Habitat Cluster, which brings together the value chain of companies and other entities that contribute to the build-up of our habitat, and using sustainable principles to do it. So for us, it's very important that projects like BIOMAT appear, concerned with what we call the bioeconomy and the use of nature-based solutions and search for more sustainable solutions that surely will end up generating products that equip our habitat, our houses, our cities, our planet. This is the scope of the cluster. And what we do in the cluster really it's just to bring together companies from different sectors, from the extractive sector to materials for the habitat sector, construction or household applications, also companies related to the entities like that with buildings and nature, and so this is a particular our field of application. So indeed, the cluster has been set up since 2009. And we have been working in this mobilization of companies and R&D centers like Senti and others that are present in this project, and that can develop solutions that are sustainable solutions for build-up of our habitat, what we call the built environment, but also the relation with the unbuilt environment, which is very important for us. So we have been doing this mobilization, developing projects, and particularly incentivize our members to develop projects in cooperation with each other. And that's the point I would like to bring here, is that we have been and Senti, the Technological Center for Nanomaterials, and also CTEV, which is the Textile Industry Technological Center, have been our members from the beginning of the class. Very important because they have this the relation also with other clusters like the textile cluster, and this allows us join projects in our members and members of other clusters from other ranks and in the value chain of the habitat. So I could give you just two examples of recent projects. One is has just recently finished 2 months ago, which is one, it's smart LSCF. We're talking about smart materials and smart lightweight steel framing, the modular constructions, and we have been involved with a company, and Senti was involved, and other technological centers were involved in this project, trying to sensorize and develop solutions that would bring a more sustainable modular solution, more versatile and adaptable to the different processes in construction and restoration of buildings. So the other project that is still going on, it's what you call the Activas project, is a project dedicated to healthy living. And Senti is one of the part also of this project, together with 20 other entities. Project that is a very large R&D project that is still it's concerned on developing solutions for a more healthy living environment, and this means new materials, healthier, sensorized environment. It has been a very collaboration since its beginning. It's one of the advantages of the belonging to cooperation between companies and technological centers or university entities have a contribute of our habitats. Been involved in also in like paper chain, what bioeconomy, because the cellulose-based wastes into involve also different companies. That has been our role since 2009, to bring these people together and hopefully to generate innovation through sustainability, which is our main goal, and the valorization of that project is dedicated on with this trying to make insulation materials more sustainable, searching for new sources and of production and in a sustainable way. This is very important for this cluster, and for us it's certainly be following, willing to and to bring together our together with the BIOMAT project. So this is basically to say is linking people, linking projects, and making it happen. So for us, it's very projects like that as being a test bed, very important for the cluster. Establish the with you, our cluster and our company logical centers.
Okay,
for your
Professor, thank you very much for your intervention. I think that the message passed well to our attendees. We have here some cuts during the presentation, but I think the main message was delivered. Thank you very much for being here today, and of course we are counting with you to help us to connect to the national companies, specifically the ones that are working or exploring the materials that we are developing here at the project. So, well, thank you very much for your intervention.
Sure. Thank you very much.
And if we receive any questions, we'll let you know, and we'll put you in contact with the persons. Okay.
Okay, I'll be available.
Thank you very much. So now we have Edgar Alexandre from ACI, which is a company working in the automotive component industry. It's also a sector where we are working in the project. Just checking if you can hear us well, Edgar.
Yes. Hello. Good morning. Yes, I can hear you very well.
Perfect. So I don't know if you want to share your screen. We can try to put it here on the wall.
Can you?
Yes, we can see it.
Can you see it?
Yeah, we can see it already. So please, you can start as you wish. Thank you very much.
Okay. Thank you. Thank you. for your kind introduction and invitation. It's for me to participate in this type of events because I believe this is the way to go. It's to close on the barriers between and the university centers, because like this we can achieve the real truth innovation. Okay. A very short presentation. A few about our company. We are ACI. We have our headquarters here in Portugal, in Guarda, which today is a little bit of a white morning since it has been snowing all night, but it looks like very beautiful outside. Manufacture compounds that are used in installation, mainly application on industry. So we have all polypropylenes, polyethylenes, PVCs, and so on. We have currently production sites in 4 different continents, and countries like here in Portugal, in Guarda, in Mexico, in Romania and Tunisia, and we are now, during 2023, opening a new production site also in China to cover a little bit the Asian market, since this is a geographic location where we have already a lot of business, but that we need to have a presence with a manufacturing site there. So our overall turnover last year was around 175 million euros. We have all kinds of let's say must-have certifications to be on our business, but I think we have also something that is a little bit the industry side, that we are certified by this management system. Okay, so this means that from the beginning, the company has put a lot of focus and effort on the R&D, because I mean, this is the only way to move forward and to achieve high levels on these quite market and industry. So we have of ours on R&D, which of 2023 about between 2 million euros of investment on R&D. And well, our products are, of course, complying with the several international standards for the automotive industry, and I would say the most demanding ones. Our based here in Portugal, even knowing that we well, one affiliate R&D team in Mexico. We will have also an R&D team in China to cover these Asian markets. We have currently, well, 12 people who work R&D. Okay. It's quite important to have collaboration between universities and technology organizations. Have very successful ongoing collaboration with. We have other acts between R&D center and the university. So we are looking for a little bit of these two types of collaborations. One is a full partnership, so it means that we have projects and with the university centers, and the other one also is that we look for universities that will help us to in some type of analysis and in some type of let's say technologies that we don't have in-house, and before the project comes to the market, we have this kind of service provider contracts with these universities and research center. Okay, so I believe that as I mentioned, the project that we have currently ongoing with Senti will be really a very disruptive approach to the current market and current state of the art for a very specific type of cables that are used on these new electrical cars. And I think this is a very good example. Companies and can and bring the let's say view and the more science-based view to bring a really product to the market. Okay, so don't want to take you too much of your time. We are a company that really promotes the collaboration between universities and research centers. Okay, I believe this is a kind of putting together on win-win situations the best of the two worlds, because there's a lot of let's say basic science that exists within universities and research centers that only with good partnerships with company they can come to the daylight, and I believe all the partnerships we have done until now have been very, very, very successful, and the outcome is really, really, really within our highest expectations. Okay, the other advantage that I see on these type of collaborations is that this will really cut the time to bring a product from the bench to the market. Okay, so a company and a medium-sized company like us don't have so that means that maybe from some of our projects, from the moment we have the idea, from the moment we get some market trends, until we find a solution that will be ready, available to the market, it's really critical. I mean, all these project life cycle is this pressure to bring up innovation and to bring new ways of facing some of the quite new technologies and innovations that has been going on automotive industry. Okay, so on the other hand, being in such a great collaboration with, for example, Senti, also give us the opportunity to go a little bit further. Okay, so that means that in some of the projects we can even go to let's say intellectual property submitting patents, and like this also create a little bit of a protection of this new technology that we are bringing into the market. This is something quite new in our company, because until now we were mainly focused on keeping the knowledge and intellectual property by industrial secrets, okay? And now with these type of collaborations, we are able to go to the next step, that is really protect our intellectual properties through patents. And this is only possible by having universities or research centers or partners like Senti to help us on this, okay? So the end of my presentation. I really appreciate very much your time and availability to listen to me, and I'm open to any questions. Thank you so much.
So Edgar, thank you very much for your presentation. I do believe that your company is one of the companies that can apply for our open tender to have access to the opportunities that the project will have. So for sure we'll be in touch during the next weeks to try to give you some additional information about the project, and maybe a different way to let's say to use this kind of materials in your final products. So again, thank you very much. Unfortunately, your presentation.
We are very keen to proceed with that. Okay.
Perfect. So now we will move forward to the new to an additional SME. Just. So I would like to ask Ana Alves from Eurospuma to present, to be here presenting the company. Just trying to. Desculpa lá, mas isto está aqui bocado confuso nas apresentações. Okay, so the floor is yours.
Thank you. Good morning to you all. First of all, I would like to thank the organization's invitation to be here. We see these kind of initiatives as taking a step further on what we can do to make our world a little better. So I'm going to start by presenting myself. My name is Ana Alves. I am a chemical engineer, and I am the Research and Development Department Manager at Eurospuma. I'm also a production engineer. Eurospuma is a family-owned company from Espinho. We have almost 58 years of existence now, and our main business is the production, development and conversion of polyurethane foams and also nonwovens or fibers. Our main goal is to become the international top comfort solutions innovator, and for that we build partnerships and develop technology for our customers' challenges. We usually say that innovation is in our DNA, and I can say one or two things about it. So we started in 1965 as a flexible foam producer by the hands of Mr. José Moraes. Then 15 years later, we introduced new types of foams, this time a pioneer type of foams in Portugal, and we also started producing nonwovens. Through the years, we set a path of introducing new technologies in the industry, developing new products, disruptive products, and also we always intended to improve our facilities and our certification systems. We started as a small company, but we are now over 200 employees, and we currently sell in 16 countries all over the world. We have also partners and suppliers from everywhere to help us deliver our products the best way. So as I said, we produce polyurethane foams, flexible polyurethane foams and non-wovens, but we also make finished products of them. We have finished product lines, more focused on the bedding industry, our main business, and also we have what we call a composite line, that is a line where we reuse and recycled our products from our productions to make new products. This is more or less our portfolio, what we can present to our clients. And as mainly polyurethane foams are materials that have special and unique characteristics, like its lightweight and the resistance, it can be applied to a wide range of applications. And we can use polyurethane foams for way more than what you all know as the sponge in your kitchens. I'm going to share with you some numbers so that you can see more or less what I'm talking about. There are in Europe at this time around 160 producers of foam, of polyurethane foam, including Russia and Turkey. And this means 1.5 million tons production of foam per year. When we talk about finished products, 90% of all the mattresses produced in Europe have foam in it, and also 90% of the upholstery or furniture are made of foam at this time in Europe. If we go to another area common to every one of us, the average car in Europe contains about 25 kilograms inside. So this way we can see why foam is so important to all of us. We can spend more or less half of our life in contact with foam. However, this brings some consequences, especially to the environmental, because of the type of material that polyurethane foam is. If we think about every year, millions of mattresses reach the end of life. In 2021, 40 million of mattresses reached this point, and that would correspond to 904 Mount Everests. Well, that is a lot, and that's why in the past years, our industry, suppliers and producers have been working together to see what we can do to make a better world inside of these consequences we make. So, just to give you an example, between 2005 and 2015, our industry was able to reduce 8% in the energy consumption and 24% in the CO2 emissions. It's not everything, but it's something. It's a path that we are building together. And to let you know also, we are giving our first steps on the chemical recycling of foam in the industry as a global industry. So we have something to look forward. In Eurospuma, we also use sustainability as a key concept for us. We try to integrate it in our portfolio, in our products, since the beginning of the company. We have a line that uses bio-based materials, and we also have, in the case of fibers, at least for now, recycled raw materials in our products. We also, as I told you before, reuse and recycle our products, and most of our products are OECOTEX certification. What better way to tell you what we think about the cooperations and this kind of initiatives, especially in the sustainability area, than to give you an example of a project that Eurospuma was a part of. It was a 2020 origin project that ended about 2 years ago. It was the Urban Rec project. In this project, the main goal was to develop and implement an eco-innovative and integral bulky waste management system. Eurospuma's part in it was to demonstrate the industrial validation of this project by using one of the developed products in the project. It was recycled polyol made with a chemical recycling process from end-of-life materials like mattresses, used mattresses, And Eurospuma was able to develop and produce a foam that contained 12% of raw materials obtained from this chemical process. So it's something that we consider that it's very important in every industry, especially in our industry. That being said, we believe that this project and these kind of cooperations are the key to our part in the world and to our part in leaving the world a better place for the next generations. Thank you all again and have a nice day.
So, of course, if you have any questions to sorry, if you have any questions to Anna, please talk to her during the coffee break, because, as I said, we have a very tight agenda, and we have also the coffee break for these things to have this kind of discussions. Again, our colleagues that are following us from in the internet, just put the questions on the chat, and we will try to reply you as soon as possible during the next days, and we'll also put you in contact with Anna if needed. So Anna, thank you very much for your intervention. So now I would like to pass the floor to David Macário from Earth Textile Portugal. Okay.
Okay, first of all, good morning to all, and thank you very much to the BIOMAT team for the invitation to present ERT in this meeting. I'm David Macário, the Innovation Manager of ERT Group, and I will pass to make a short presentation of our group, what we do, the industrial processes we have, and how we can collaborate with this project. So, ERT is a Portuguese-based company that works that produces laminates. The core business is the production of laminates and technical textiles. Our main market is the automotive industry, but inside the group we have other small companies more focused in the technical textiles for footwear, for protection, EPIs, etc. Also, we have a small adhesive company that supplies, that does polyurethane adhesives for the footwear industry. Because we work, a big part of our work is for the automotive sector, we have different plants distributed in the world. Okay, and the idea is to be near our clients, okay, to reduce the logistic costs, okay, and to gain efficiency and also be more ambient friendly. In numbers, you have here some numbers about our turnover, our number of workers, and the plants we have now open. As I tell you, ERT Group is an industrial company. We have different kinds of industrial processes that can be used to produce different kinds of products. We start with the lamination. We have different kinds of lamination processes to work with different kinds of materials and characteristics. Cutting technologies for different kinds of materials. The sew, okay, manual sewing, CNC, decorative, functional. The covering process, that is mainly cover plastic or composite parts, we hope so. In the future, plastic parts mainly for the interior of the car, pillars, door panels, and so on. And also we have an unit that produces foam in place, that makes foam in place injection, mainly for the armrests for cars. Okay, but we have is a robotized line, and we can do all kinds of parts using polyols and isocyanates injected directly in the mold. With this set of processes, as you already understood, we can start with the fabric, the PVC, the foam, the TNT, whatever, glue it, okay, make the laminate, and later cut, sew, cover a plastic part, okay, to obtain a final door panel, door medallion, armrests, whatever could be the part for the interior of a car. I have a small, very short video about our group. We don't have sound, but no problem. And the idea with this video is to show you some of our industrial processes. We are based, as I tell you before, in São João da Madeira, and you have some examples of what we do. In our case, we are interested on the lamination of big rolls of foam. Okay? We are interested in obtaining the foam in roll, okay, to laminate. I don't tell you this before, but we are in the sector for about 25 years, so we have all kinds of certifications to be present in the market and to comply with the requirements of the automotive sector. Also, in 2014, we acquired the certification for innovation, and we have a dedicated department with a laboratory to conduct research work. For the rim or foam in place process, we use, for the people that don't know, we use the raw polyol and the isocyanate, okay, and we make the controlled mix in the mold, okay, to obtain a foam part. We have different kinds of partnerships with the major actors in the scientific and technological field in Portugal, also in Europe. We are members of also the main innovation and research clusters in Portugal. And we have a set of ongoing projects, most of them focused in the bioeconomy, okay, sustainability, and also in the digitalization and functionalization of interiors, okay. And if you want more information about this project, we can talk later. But okay, you have here some of them. Last week we started a very important project at Finland, the T Extended. We've been present with our colleagues from CTEV and from other companies in Portugal. The aim of this project is to create an optimized network in Europe, a network of residues providers, ways to make the transformation of the residues, okay, and also have final consumers of that rejuvenated residues, of these raw materials obtained from the residues to make new parts, okay. ERT will participate on this project as a provider of residues, as a provider of requirements for the raw materials, and later in Work Package 6 as an integrator and as a manufacturer of new parts with these new materials. We also have a project related with the resilience program in Portugal to start, but more focused in the digitalization of our production means. I have one example of a product developed before and focused on the sustainability. Phoenix is a coating, a material to use in interiors, similar to synthetic leather. What is the difference of this material? We obtain this material from the recycling, the chemical recycling of automotive leather cuts and scratch, okay, combined with new polymers and using a backing from recycled fibers. The product was developed, the basic research of the product was done on Text Boost project before, also working with Senti and CTEV. We have an ongoing project to develop more this product. Now we have a version that can be used in fashion, also in furniture, but we want to develop more the product, okay, to go forward to the automotive industry. I would like to thank you and to give you and to share with you our interest and our openness to collaborate with this project, with the team, using or put at your disponibility our industrial processes, and also open to talk later about some ideas to develop some of the applications of your research. Okay, thank you very much.
So, thank you very much, David. I do believe there will be some synergies, specifically in the adhesives part, probably, but for sure we can talk later on. So just moving to the next company, I would like to ask Vitor Coimbra from Flex 2000 to come to the stage and to present the company as well. So I'm just changing here the presentations. Sorry, sometimes it takes more time. Perfect. So, please, thank you very much. Thank you.
Hello, good morning. My name is Vitor Coimbra, and I'm in charge of chemical production management at Flex 2000. I work in this charge since the last 32 years, and I'm also involved in the R&D department in a direct approach. I'd like to make a small and very simple presentation of the company. If one of you want to know more about our company, you can reach our webpage or talk with us to know more about our company. The goal is to give you a very overall idea about our company, the main figures, nothing more than that. So the Flex 2000 is a family company, was founded by Mr. Manuel Pereira, and now is run by his son, Carlos Pereira, is the actual CEO. And also the third generation is taking the first steps in the business. Only some numbers about our company. Flex 2000 was founded in 1999 after a huge fire we got in the old facilities. We got a fire in July 1998, and in the day of the fire, the owners decided to create a new plant just to produce exclusively polyurethane foam, because before we share the same plant with another company of the same group, producing ropes, natural and synthetic ropes. And in the day of the fire, we decided to build a new plant where we are now in Ovar. Last year, we got estimated turnover around 210 million euros, and we have installed a capacity over than 60,000 tons of foam. We used to say we are probably one of the biggest foam producers in the world. And we have a very funny video. You can reach it in the web. We have very, very funny numbers of our production capacity. Effective production nowadays is around 50,000 tons per year. This is a huge amount of foam. Of course, because the capacity installed is bigger than our production, we are always intending to create more space, what is very difficult in our country, as you know. At Flex 2000 works around 270 workers, and we know the ratio between our production effective production and workers is probably one of the best as we know. This is a photo of our plant in Ovar. Nowadays it's very small for us, for our goals. Nevertheless, it's one of the biggest in the world as a unique foam plant, and we have no more space available for to build more facilities, but we need, and we are struggling to get more space since the last 5 years. Probably in the next 2 years, we will start expanding the expansion of the plant. Besides the actual production is not enough for us. Of course, the natural market is Europe, but we are too much big only to supply Europe, and in general, we supply worldwide. It's difficult, but we try to be efficient in order to be competitive, to be possible to export worldwide, and to give to our customers a good product and a good service in a good time. This is in a very, very simple way to show you the main products we produce. There are two main families of foams, ether foams and ester foams, and there are some foam types we produce. Some of these types include some bio-based raw materials, and since the very first beginning, when the market gave us the possibility to use these bio-based materials, we started the new projects of new foams, including bio-based raw materials, mainly polyols. I remember some years ago was BASF launching the called balance polyol, and we were the very first foam producers using this kind of bio-based polyol. We still use this bio-based polyol and other bio-based raw materials in order to have the possibility to offer to the market a cleaner and safer products. It's very nice to hear this sustainable and efficient words, but it's important also to say it's not easy to sell foams with bioproducts because it's more expensive, and the main customers are not interested in paying more for better. They want more for the same price, and this is the big challenge for us. And I would like to share with you the big difficulties the producers have to produce new developments based on biomaterials, because many of them are more expensive than standard products. This is a barrier, but we are here to pass the barriers and to get more efficient projects in order to be competitive with better products, mainly in bio-based materials. This is a challenge I would like to share with you. It's nice to sell materials or products with bioproducts, but please don't forget the competitive perspective. It's very important to get this in mind. Also, we produce rewounded foam is a different way to say we recycle our foam scrap, but this is a very known process. And since a long time ago, we are also working together with European companies about the chemical recycling of scrap, of foam scrap. Once again, we didn't yet take any decision because there is the risk of a big investment, and at the end, we can't sell the foam. So, we are a private company, and of course the profit is the main goal. We cannot be producers only to produce products without have the idea of the final results at the end of the year. It's not the first time I be present in this kind of workshop, and I always tried to underline this difficulty of foam producers. Bio-based materials is very nice, but please don't forget the impact on the final product, on final price, on final costs of the development of new foams. Mainly, in my perspective, is flexible polyurethane foams. Like Anna told, polyurethane foam is present in our lives, wherever we are. The main market for polyurethane foam is bedding, upholstery, furniture, the comfort applications, but also many other markets, many other applications, not only these, but also other not here explaining. This is our brand, and as you can see, BioCell is a very old brand we have specifically using bio-based materials. If you ask me, do your company sell a lot of this foam? No, unfortunately. The market is not sensibilized for this question. They are not open to pay more for green products. Please don't forget, help us to develop more competitive green products. Thank you very much.
So, thank you very much, Vitor. I think it was a very good vision about some of the points that we discussed yesterday during the project meeting. I think we are aligned with the main concerns of Flex 2000 and not Flex 2000, sorry about it. But I do believe that we can essentially discuss a lot of things, a lot of points that we touch in your presentation, because there are a lot of partners here that are working specifically in each of the main points that you mentioned, specifically the recycling part, specifically the pricing strategy. Well, all these topics could be very interesting to discuss with them. Okay, so thank you very much for it. So the next company is TMG. I would ask Elena to join us. TMG Automotive. Sorry, it's important to mention that part. So, please.
Good morning, everyone. Thank you. Good morning, everyone. My name is Elena Aguilar. First of all, I would like to thank the BIOMAT project team for the invitation addressed to TMG Automotive, but most of all to my former colleagues from Senti that organized this wonderful workshop. So it's very nice to be here again and see all these familiar faces, not only from Senti, but also from previous European projects that was also involved. So TMG, so I'm representing now TMG. I'm responsible for the pre-development group at the R&D unit. TMG is located in Famalicão, and so very close to Senti and Citev, but also in Guimarães. We have also a facility. So TMG Automotive in particular is located in these two sites. So TMG was founded in 1937 as a textile-based company, but soon, 40 years ago, or 15 years ago more or less, started in the automotive sector. Presently, we are around 700 people, and I can say that the number of people dedicated to R&D at the moment is increasingly very fast. It's increasing very fast, and we are now more than 80% dedicated to R&D activities at the moment. We are running more than 40 R&D projects internally, which means that apart from these 40 internal projects, we may have 10 to 15 projects, R&D projects, in collaboration with academia and research institutes. So we are, in the automotive sector, we are a second tier, which means that we don't supply, we also supply the OEMs, the automotive brands, but we mainly supply the companies that are responsible to fabricate automotive components, okay? And mainly our role in this product value chain is to produce polymeric materials, so what we call typically artificial leather materials based either on PVC, thermoplastic elastomers, and also polyurethane chemistries for dressing, let's say, the interior of the car. Of course, working in the automotive industry, we have to be certified, so we have a lot of certifications since a long time ago. And we are also applying now for the standards for dedicated to sustainability. So, of course, our natural market is Europe because all the major brands, automotive brands, are located in Europe. But we are establishing a partnership with Arts and Mint both located in United States and China. And we are starting now producing in a collaborative way in these two places as well. So we supply OEMs basically in Europe, as I said, North America, Brazil, China, and also South Africa. These are just a few of the brands that we supply, okay? And I will show very briefly some examples of what brands that we produce and what kind of materials we supply to them. But I will then show you a video where you can see the materials being produced, because I think it gives you a better idea of what we produce and how we produce materials. Okay, this is just one example. So we dress the instrument panel, the door panels, the seats, inserts, armrests. Our core business is PVC still and thermoplastic elastomers, but we really want to focus our production also on polyurethanes. And this is the topic of this workshop, of course, I know that. Because the perceived quality of polyurethanes is we know that is very well known by our clients, but as it was already mentioned today, the price of these materials is quite high compared to PVC or other thermoplastic elastomers, so we need to convince our clients that we are moving to a much better quality materials and more sustainable materials, okay? So this is, again, Daimler or Mercedes-Benz now, mainly PVC materials that we produce for them. Volvo was one of our main customers and one of our first customers. And now again, Polestar with the hybrid and the electric vehicles. Also Porsche, Jaguar, Land Rover. And yeah, this is the location of the plant, where we divide the production into PVC on one side mainly, here in Famalicão, and TPE and polyurethanes in Guimarães. Just a few examples of developments or innovations that we carried out in collaboration with the research centers. Senti is one of them. So we are trying also to incorporate functionalities in these materials and also to improve the sustainability. This is also a good example that is already very close to be in the market, which in this case we are trying to incorporate natural fibers or natural particles, in this case cork, but it could be cellulose or hemp, because the clients are really requesting these kind of solutions to make materials more sustainable. And this is one of the oldest innovations, the first ones that we made on the inkjet digital printing for Toyota. Okay, just to briefly say that the innovation is a core topic at TMG Automotive nowadays, and we want really to improve this collaboration with the scientific and technological partners. I myself, I was a researcher for more than 20 years, and I moved to TMG only in 2019, and I'm one of the best persons to say the benefits that these collaborations can bring to innovation and to put really disruptive products in the market, and both parts can profit from that strong collaborations. So CITEV and Senti are here, of course, naturally, but also Fraunhofer, let's see, so many of you that are here today. So we also have a department, sustainability department, that is really strongly working on this topic. We are certified now according to these standards to meet the requirements of our clients. And as I promised, so Antonio will help me to show the video.
Yeah, there are some tricks.
Yeah. So if you have questions, please address them to me in the coffee break or even through my email contact. This is a 3 minutes video, but I can explain some parts of the video. So these are the typical materials that we produce for different applications. We are now focused really on the demand, the request from our clients to make materials more sustainable, more vegan, animal cruelty-free. These kind of buzzy words that we all hear but are increasingly getting importance nowadays. These are our labs, so we have a very strong, very large team to test materials that we produce according to the OEM standards. I would like to have more equipment, but it's not possible at the moment. And we do have some quite nice facilities to perform R&D activities, but I think we could be much better if we strengthen the collaboration with academia and research centers. The BIOMAT project is a very good example of this possible collaboration, apart from others that we already have, as I mentioned, with many of you that are here today. So this is the coating line, the knife coating line, where we produce the PVC and polyurethane-based materials. So it's an indirect transfer coating. And then we also have extrusion process to fabricate TPU and TPO materials, also for some particular applications in the car interior, mainly for instrument panels, door panels. So if you are all invited, if you have the chance to visit us at Guimarães or Famalicão. Famalicão is a much newer and well-equipped factory. This is the building, the headquarters of the company. So thank you very much for your attention, and please feel free to ask any questions or in the coffee break or afterwards. Thank you very much.
Okay, so thank you very much, Elena. Also, a good overview about the automotive sector and a very close, I would say, a very close collaboration with Senti that TMG has during the last years. I'm quite sure that TMG can also benefit from some of the opportunities that we'll have in BIOMAT. For sure, we'll be in touch with Elena like we have been during the last years. Yeah. So now we are a bit delayed. because we also start a bit late. Sorry for that. But I would like to invite Albertino Oliveira from SEDACOR for the next presentation. I'm just trying to move here. Okay, perfect. So, please.
So, good morning to everyone. It's a pleasure to be here. Thank you for the invitation. Today we speak all about sustainability, about the future, about what can we do about that. And as among all the people in this place, mainly I can say that most of you are from other countries, of European countries, besides Portugal. Let me introduce to you, if you don't know about that, one of the main raw materials that Europe, and mainly Portugal, has the ability to offer to Europe and to the world. This is probably the most sustainable forest material of Europe. And Portugal leads this market, leads this forest, and leads all the products that can be developed to the world from this incredible material. I used to say that this is a spice, this is a gold from Portugal. Cork is 100% natural, 100% reusable, and 100% recyclable product. It's probably one of the most astonishing natural materials and versatiles from the world. Light, soft, resistant, compressible, insulator, impermeable, all these natural features, together with technology and love to the product, can lead us to have new solutions for the future of mankind. With a negative carbon footprint, Cork Forest, where Portugal is the one that has the most biggest cork forest in the world, are one of the 35 world's hotspots of nature, with an astonishing ability to absorb up to 15 million tons of CO2 per year from the atmosphere. Just imagine that each ton of cork that we use every day ejects from the atmosphere 73 tons of CO2. I don't know any other product that can make that. And with a little detail, we don't cut the trees. We just pick up on the skin of the tree and pick up every 9 years. And as much as we pick up cork from the tree, as much as better the tree itself grows. So this is an incredible balance that we try to develop further, more in the future. Our company is a family company also, as some of the others that were presented today. We have an annual turnover of around 40 million with our company, SEDACOR and others of the group. We have 102,000 production area spread by several factories. We are in more than 50 countries in the world. Our main markets are Europe, Asia, and America. So, in terms of great product areas, we have 70% of turnover bring by cork stoppers, the main product for all the cork industry and also in our company. But we also have other 30% already with new applications, with other forms of satisfy human needs, like products products for construction, for insulation, for decoration, for fashion, for textiles. And as I used to say, the origin is unique, the applications are endless. So more than 85% of all our business is for other countries beside Portugal where we are based. I would like to have some small figures, but important figures. Every day we recycle more than 50 tons of cork. Our policy is to bring more and more ideas to how to have our planet better and better every day. So we have already the possibility of having 10% of our energy is from photovoltaic panels, 10% of energy also for biomass burning. This is already on facts, and we are still working to even go better in these numbers. And I used to say that every day we try to put some people happier. So every day 3 million bottles are opened with our cork stoppers, okay? And this is not only a matter of serving the market with the best insulation for wine. For each bottle that people use with cork stopper, we are reducing to 150 grams of CO2 carbon footprint per bottle. This is amazing. And this is the best way to avoid the liquid to go out of the bottle. So we are mainly settled on Portugal. Our base is on Santa Maria da Feira, so 25 kilometers south of Porto. And we have also one factory on the middle of the cork forest in south of Portugal. So Sedacor 1 and 2 and GPS has factories on Santa Maria da Feira, Sedacor 3 on the south of Portugal on the forest, and also had a new factory, which is a result of an important project with a partner company, organization from Centro de Citev, which was a new Corcatex yarn, which is called Corcatex company itself, and is here in Guimarães, nearby Famalicão. We used to say that we are a global cork products provider. We have, since 1924, so almost 100 years, tried to have solutions of cork for several kinds of applications, like winery, the first one, decoration, crafts, textiles, fashion, construction, furniture, packaging, footwear, sports, and even automotive. We are starting also on that area. And so we can make stoppers, floors, walls, insulation materials, products for wellness, and fashion and textiles, besides all the others. I was asked by CITEB to answer to some questions on this brief presentation, so I'm trying to answer now. Products from ED, just some examples. 2 new cork stoppers, technical cork stoppers, cork and roll fabrics, dynamic cork 3D walls, cork floors in rolls, cork yarn, among others. Some examples of these products. Cork stoppers, all kinds of cork stoppers for wines and spirits. Construction insulation, cork granules, rolls and sheets. Remember that cork is a great thermal and acoustic insulation, so you can make both things with a sustainable way. Cork floors and walls, one of them, which is in roll, is the first floor in roll of the world. So we have new products for us, and we have made also new products for the world, like this one. We're the first ones to do it. Also cork fabrics and cork yarns. This one is also one of the most important prizes, as you must know, textile fair. This one's the new material textile in 2019. And much more. So products for sports, for packaging, for household, for furniture, for wellness, even for football. You know, many people don't know. If you see on that corner on the right behind is a kind of green thing, which is a kind of small example of a floor of a cork of a football match, you know. this now is using also cork for this because it is a great product substituting artificial materials to absorb impact from the people and avoid to have more injuries to the players. And also now answer to some questions from Sentry. Previous experience on R&D projects. We have experience in a partnership with R&D organizations and universities like CENTI, CITEV, which is textiles, CITICORC, CORC, CTCP shoes, STIC leather, University of Porto, University of Aveiro, University of Lisbon, all in Portugal, of course. What were the added value of those collaborations to our products? Successful knowledge and relationship with ID governmental projects, new products and developments know-how, fundamental applied research. A medium company cannot do everything in the correct way. You must ask help where we can and when we want to make something real for the future. And real that can have some competitive advantages for the benefit of the consumer. State-of-the-art science and engineering process, new composites, new products, new applications, product tests and certifications. Previous experience with R&D projects. We have two types of collaborations mainly, projects and service providing. What were the barriers or are the barriers when asking help to such organizations? Bureaucracy sometimes, possible interest conflicts with other client companies from these organizations, and costs when we don't have some support of the EU or Portugal. It's not easy to go to everyone when we are a small or medium-sized company. We must have some careful about that. So, thank you. I tried to be very short as I was the last one. And let me say, welcome to the future. And just to say, I want to say one other thing to my colleague from Eurospuma. FlexiPUR, Flexus Mill. We are neighbors, but let me say to you that I disagree with you in part. I agree that the most important challenge that we all here have is to substitute synthetic materials by natural materials and adhesives. And there is no way to avoid it. And even for cars industry, 3 years ago, we said electric cars are very expensive, very expensive, very expensive, but now we are buying electric cars. Also for cork stoppers, it's the most expensive product for selling the bottles, but is the most successful product for selling bottles. We must join sustainability, function, and these two ideas, sustainability and functionality, if we do it well and market gives value to that, there is no problem. Thank you. By the way, a great choice. This notebook is with cork. Remember, you have a proof of what is cork, and even for this notebook, if you have here 100 grams of cork, it means that you are capturing almost 1 kilo of CO2 per this product. Thank you very much. Yes.
Okay, so thank you very much, our team. As you all noticed, we invited Sedacor to this workshop not to show how they are using foams, because they are not using foams, but to show that the combination between research centers, universities, and companies are always very well welcome and can really reach the market with new products. So we do believe it's one of the main goals that we have in BIOMAT, which is combine or giving the opportunity to SMEs to try to use to get more knowledge about some specific topics. So SEDAC, our presentation was only to demonstrate as well that it's possible with all these different opinions, I would say, but it's possible to do it. It's a question of do it and invest probably a bit on that. And BIOMAT is at this moment is giving free, I would say, free support on it during some months to develop some specific materials for foams and for adhesives and on all the other technologies. So please keep it in mind and take a look to the website and see there how the opportunities you will have. So opportunity, you were not the last presenter. We have here Bruno Santos from Morocco. And Bruno will also say something about the use of different materials or some of BIOMAT materials in their application. So, please.
Good morning to you all. Some of you know me for yesterday. I'm here today to replace my colleague who unfortunately cannot be present for health reasons with a familiar. But I'll try to help to talk a little bit of what are you doing here. So our company called Morocco. It's a company that buys and sells essentially foam. That foam that all of us have in our houses, in our sofa, and a lot of things that we use in our mattress, for instance. So I will try to explain a little bit the consume of the foam that we have, and we don't even think about it. I'd like to say that it's very important for us, this BIOMAT project, to develop the 100% recycled foam for sustainability, of course, with bio-based materials, through nanotechnologies, in order to better protect the environment. For you to understand, we have an area of 3,000 meters squares with a height, I don't know, something like 7-8 meters high, full of foam between buying and selling. It's always full of foam, and we are just a little part of the consume of the foam. I'll give you an example. For instance, Flex 2000 sells last year, if I believe, 210 million, right? Something like that. We are just a small company. We buy them something like 2 or 3% of their production, just a little bit. And we have an area of 3,000 meters squares of foam, full I don't know, I think we have 6 or 7 meters of foam. It's a lot. Now I'm going to explain what quantity of foam does that represent. For us to make a sofa, for you to understand, we only need a board, something like that, a board with 2 meters for 1 meter point 2, and that's more than enough. It's the media for us to make a sofa. So for you to understand the comparison of one sofa and the production of Eurospuma or Flex 2000, it's something that we really need to think of. It's very important for us to recycle, to develop for the recycling, okay? I'm sorry for my English, I don't practice a lot, okay? We are a company that we have more than 2,000 clients in several areas. They consume constantly the foam that we buy, all of us buy today. So I would like to talk a little bit of other project that was very important for us to protect the environment. It happened with the partnership of CITEV, CENTI, and I3S a few years ago that we developed a machine. This is for you to understand how do we want to protect the environment. It's very important for us, but because we don't sell only foam, we sell every kind of material that is needed for instance, to make a sofa. Everything, since the fabrics, the foam, and other pieces. So it's important for us to improve another kind of articles. We developed, with this partnership, a machine that can treat the fabrics in order to protect us, our healthcare, every day. I'm sorry. That machine can bring us to the fabrics other targets. So we can make, for instance, a fabric with water. We can treat a fabric to be with waterproof or an unflammable or antibacterial. That machine that we developed, it's the only machine in Europe that is able to do that kind of treatment. Okay. That machine works with spray coating, okay, instead of diving the fabric in the liquid. It's just a spray that allows us to save much more water and a low consumption of the chemical used. We could reduce that kind of consume. So with that partnerships with CITEV, CENTI, and I3S, we always developed a few formulas that are very important for us. It was possible for us to create a formula that inoculate coronavirus. Okay, it was was a new all over the world. It was very important for us to project us to create another and bigger dynamics to go further. Nowadays, we need more challenges. We need to grow up a little bit. We need to create new treatments for another bacteria, like E. coli or Legionella. It's very important for us. We'd like to create a filter to use in hospital facilities to I don't know, use clean water and other liquids in order to not allow Legionella virus to go around the hospital facilities. That exists, we don't know, no one tells us, but that exists because an hospital can say someone died because they didn't have the conditions needed. We think we can develop this kind of investigation with our partners. It's very important for us. Sorry. I'd like to ask the partners. We were talking yesterday about the foam. We are very interested in foam, in foam 100% recyclable, but it's very important for us. I think this work is being done or is about to be done. We will need to make a lot of that because it's very important for us that consumes, that sells foam to avoid with these new changes and developments, to avoid some kind of reactions. For instance, it's very difficult for us to work if the foam has a physical reaction. For instance, if it gets too hot when we are in our bed, in our mattress, it's very important for us to avoid that kind of reaction. So if we are trying to develop a different kind of foam, I think it's very important for you to think on that because in practice, it's very important to have that characteristic. Okay? I think that's all. I won't talk much more. I'm just replacing my colleague. Okay, thank you all.
So, thank you very much, Bruno. Morocco is a partner of, let's say, it's almost a partner because European Sky is part of Morocco. It's almost a partner of BIOMAT Consortium. They are one of the end users of some of the developments that we are doing nowadays. We invite them to join us today because basically it's a good example of what this kind of projects involving pilot lines can basically bring to the market, because they had a project that ended 1 year ago or 1 year and a half, in which they were involved in the development of a spray coating line. And at this moment, the line is installed and they are using it to produce things to the market. So it's really important to highlight that, let's say, European projects are not only projects. It really can bring something more at the end, not only for the partners that are involved, but also for the industry. So we are a bit delayed, as you all know. We have, I would say, 20-30 minutes delay. So we would suggest you to have a break now, to try to discuss with the companies that were presenting here today. Maybe I would say 15 minutes, and then we will come back to present you the pilot lines that we are exploring in BIOMAT projects. And we will also discuss with our colleagues from the horizontal services, because maybe there will be a small change on the agenda because essentially because of the time. But I will update you after the coffee break. Okay. So thank you very much. Enjoy your coffee break. The coffee break will be downstairs on the left, but probably my colleagues will be there to guide you. Okay. So, Giuseppe, sorry, Giuseppe from CNR, who will present one of the pilot lines. So, please.
Thank you very much. Good morning, everyone. My name is Giuseppe Cesare Lama. I'm from Italy, Naples, and I will show first where we are in Naples located and the pilot line. So, okay. We are involved in BIOMAT project as pilot number 1. We will produce nano-enabled polyurethane rigid and semi-rigid panels. And actually, we have 2 different pilot plants, hybrid 1 and hybrid 2. Is it visible? Okay. Me, together with Dr. Letizia Verdolotti and Dr. Roberta Marzella, will are reference people of the CNR EPCB. We are an research institute, Pesquisa Institute, placed in Naples, and have different different locations in the north, in the center, and the south of Italy. The CNR, as well as our institute, have different competencies, like polymer chemistry and hybrid composites and tissue engineering. Everything is devoted to societal challenges such as energy, transport, and health, as well as packaging and buildings. So, getting down to business, this is our pilot number one, in which basically is made of two different sections. The first one is where the storage are, you may know better than I do, with the two different silos in which polyols and isocyanate are stored. And at the end of this storage, there is the mixing unit, which is basically an extruder which truthfully mixes the isocyanate, the polyol, the isocyanate, and the filler, because we are aiming to produce nanocomposites in this project. This is how it is built. On the left, you can see the extruder and the mixing and the foaming unit. And on the right, the two different storages of component A, the polyol, and the component B, the isocyanate. As you can see here, how after the polyol is added to the mixing machine, is then the turn of the filler, and then only at the end of the extruder there is the isocyanate. This will allow the reaction of the polyol of the component A with the component B, and then after the foaming happens, and of course the molding. The second hybrid pilot essentially is a discontinuous one, and is made of again two different storages. I don't know, maybe you can see the red one is where the isocyanate, of course, is stored, and the yellow one is for the component A. Is controlled by a digital panel, and also there is the filler input, and the mixture happens in this cylinder. We can try the video. Okay, so this is the main, the core mixing machine. There is an operator, our colleague Federica, and this is the mold. We can produce different dimension panels. Those are the storage, and this is where the filler is put. This is we are producing 20% content of filler in this precise example. This is, of course, the mixing phase, and this is the foaming process. I didn't turn off the audio. Sorry. This is the foaming, and this is the dimension of the panels. So we are now producing this kind of composite material. Okay. Okay, so in the end, the pilot main products and characteristics are from chemicals for production of bio-based composite polyurethane foams. That's what we need, and thanks to the consortium of the project, of the BIOMAT project, we have bio-based polyols, isocyanate, and of course the fillers, which will be used as planned around 40% in weight. We are aiming to have performances in the order of comparable with those of the standard materials, with good thermal stability and thermal insulation. as well as fillers which are homogeneously dispersed within the foam matrix. And from a sustainability point of view, our aim is to reach up to 50% of bio-based content, and with a complete replacement, at least of the component A, the polyols present in the component A. Of course, those are most relevant applications in terms of rigid and semi-rigid foams, soft and semi-soft foams. And one of the fields we are also devoted in terms of semi-soft foams is the production and the optimization of a bio-based formulation for steering wheel, foamed dashboard, and also the cushion of the Automotive. This is everything for me. Thank you very much.
Thank you very much, Giuseppe. So now we'll move to the second pilot line, and it will be presented by Sergey. Can you? Good. From.
Yes. Thank you, Antonio. Hello, everybody. Also from my side, I'm going to go through the presentation of pilot line dealing with development and upscaling of soft foam formulations. First of all, for furniture and bedding applications. We installed a respective pilot line at our facility. This is University of Applied Science in Kaiserslautern, in German Hochschule Kaiserslautern. And my name is Sergey Grishuk. I'm representing our team here. According to expertise in our group, we decided to represent this by professors groups. As you can see, we have experience in polymer chemistry, polymer science analytics, also organic chemistry, as well as in textile engineering, so primarily technical textiles. Here you can see just advertisement for our pilot line based on different metering units for various components, and also on the left hand side you can see the production part, and we also have a fast wire cutting unit in order to provide our partners and customers in our testbed further development with desired shapes of the soft and semi-soft forms. So here you can see the real picture of the line constructed to our facility. We call this room BIOMAT room because everything being there is related to the BIOMAT project, and testbed should also function even after project end. So that's why we decided to rebuild one of laboratories exceptionally for this purpose. Maybe I have to stress that using this line is looking not very big. I will share with you a short video like BIOMAT laboratory tour. You can get slightly better impression regarding this. Actually, we are able to run in one shoot, if you fill all the tanks for biopolyol components, up to 200 liters of polyol component at once. So this is benefit because line is compact, but we can produce some test series without continuous refilling of the tanks. And of course, we are flexible in the metering of additives, and also we are able to compound with field systems. I don't know, it's not very clear to see here. One of polyol tanks is equipped with a mechanical mixer just to keep the dispersion continuously homogeneous. So this was also a decision related to BIOMAT because we are dealing with nano-enabled systems, and it's very important to have at least one such metering line being also able to process some dispersions even with higher viscosities. Here, promised laboratory tour, hopefully it works. So you can see here some equipment. ResiMat is for determination of viscoelastic properties of viscoelastic forms. We also have format equipment for determination of forming parameters. You can see this equipment here. So everything is standing next to the producing part of the pilot line here. You can see also from the behind. And we also have a CO2 forming unit being more and more popular even in the industry last time. And stationary fixed mixing head at that moment, but maybe in the future we will think about the upgrade also with some transport line behind this mixing head, just to get more flexibility in producing the form blocks. So here you can see the main characteristic of metering units. In the total, you see we have 19 metering units, including CO2 forming unit and also nitrogen protecting unit just to create inert atmosphere during processing of the form formulations. We can run our line in both continuous and discontinuous, so batch-like manner. And here you can see average characteristics for this line constructed for us. The average shot volume, we can deal with more or less 5 kilograms per batch. And depending on the formulation, we are processing the viscosity of components and so on, etc. We can also deal in the range of shot speed between 2 and 25 kilograms per minute. When we are dealing with continuous production speed, 10 kilogram per minute is a recommended one. It can vary, but we try to keep this as a maximal, and this is related to the limitations in the metering speeds of the unit. The maximal metering speed is related to the basis polyol is 15 kilograms per minute. So here, just for better impression, we cut some short video with my colleague Philip as the operator, just to give you some impression how does it look. So here you can see the first part, we have to move away the materials being in the pipelines, and after the mixture is stable, we can fill the mold. Here, the lucky guy with a block produced in such manner. And of course, we are interested into cutting inside. This time you can see it's manually cut. The cut is not very nice. And the cup of this block you can find here on the table. Afterwards you can touch. We brought some representative samples of our preliminary developments on bio-based formulations. And the bio-based content, I think in these samples is up to 60 weight%, but we already realized also nano-based content of 75% in the last time. And of course, when we create new knowledge, we have to share this with our students. That's why the third picture is also here with different types of forms, including also some rigid forms being not related to BIOMAT in our activities. So regarding the performance of our line, I have to stress that we are able to develop the new formulations and upscale them even for nano-enabled bio-based formulations. And of course, we have to orient us on the specifications of our customers. And in addition, we can also test not only the new biopolyols, for example, or bio-based components. We can also investigate the influence of different additives. The independent controlling of the metering of these components provides this opportunity even in logical test series or according to recommendation of our partner using design of experiment just to reduce the amount of experiments to logical one. And of course, we are oriented on the slab stock production process, and we hope that our line could provide beneficial knowledge how to transfer the processing parameters easily to real, at least small industrial production lines. And further benefit to stress is also semi-automated operation mode on the line. Regarding the sustainability, we already realized using bio-based polyols as a first approach for increasing the bio-based content by total replacement of petroleum-based ones. In the last time, we collected a lot of knowledge also using available bio-based isocyanates, some additives, and we are ready to upscale also nano-enabled formulations being developed on the lab scale. We are also trying to use sustainable blowing agents, or in many cases even just water. There we have some limitations in amount of water which could be used because of some exothermic effects when we are upscale to larger scale. And when we are running the test series, this loss of materials after cleaning the pipelines by new formulation is kept constantly. It doesn't matter how many runs we are processing. That's why the material loss, especially in relation to additives, can be evaluated as quite low. So here you can see some pictures of similar samples like those on the table, and also small cohorts based on our first bio-based formulations. Our colleague Laura created this sofa. Unfortunately, we didn't take this time the sofa with us. We represented it already at the first workshop, but at least you can see the picture of it. Regarding the other relevant applications, actually this line is allowing also running test series and experiments for other different form applications, including rigid forms. We have some limitation with the viscosity at the moment. Later on we will upgrade with some additional metering lines in order to come to higher viscosities also. And without the blowing, we even can develop the casting formulations on bio-based polyurethanes. Thank you very much for your attention.
So thank you very much, Sergey. Let's move to the next one. It will be, sorry, just changing here the presentations. So it will be Dario Martin from University of Castilla-La Mancha, correct? Just opening here. That's it. Okay, perfect.
Good morning to everyone. My name is Dario Cantero Martin, and I am the representative of the University of Castilla-La Mancha, who is going to talk about our pilot plan. Our plan is based over the insulation aerogel panel production through the freeze-drying technique. The research team involved in this project is part of the permanent staff of the Department of Chemical Engineering on the University of Castilla-La Mancha, located in Ciudad Real, Spain. In the fields of conventional and electrochemical catalysts, the team has gained some experience in the areas of alcohols reforming, Fischer-Tropsch, and water gas sieve process, among others. It has gained some expertise in the synthesis and characterization of carbon and carbon-nitrogen nanostructures, the synthesis of aerogel and other composites, and the production of encapsulated materials and catalysts. This profile allows the group to face some different challenges, such as the development of new synthesis routes for carbon and carbon nanostructure materials, the synthesis of other inorganic materials, and the design, simulation, scale-up, and optimization of some different chemical processes. Talking about our pilot plan, it is able to go from lab scale, producing only 0.36 square meters of aerogel per batch, up to 2 square meters of final product per batch. It's necessary to say that this production depends on the thickness desired for the resulting material. Our pilot line consists in a semi-industrial freeze dryer, which is a compact unit with casters, constructed in a steel stove-enabled cabinet. It has a vial stopper ring, an spacing device, an isolation valve to condenser, a microswitch software, and a vacuum pump with exhaust filter. The system permits to control the freeze dryer functions by using a human interface machine that provides information about some different system parameters, such as the outputs of the different alarms that may appear during the different processes, and also allows to modify the different parameters of the freeze drying cycle. All of them while protecting the system from unauthorized use, and also permits to do some different freeze drying recipes development. As well, a vacuum sensor is installed to control the pressure of the product environment, and the monitor of the experimental conditions can be done really easy, allowing to interpret the final results of each experiment. As well, we can control and improve the energy consumption throughout all the process by changing the different recipes that may be useful for each kind of material. This semi-industrial freeze dryer allows to obtain some different value-added products while looking after the environment throughout all the process. This is achieved by using solvent-free processes. This is using only water as a unique solvent, not using expensive reagents, with environmentally friendly synthesis routes, and all of them while reducing the energy consumption by controlling the different parameters that I have already mentioned before. Comparing this technique with the classical supercritical drying, which is the other drying technique related to the aerogels, it's necessary to say that this technique consumes much less energy, obtaining some similar products while reducing the overall cost. So our main products are aerogels, which are some ultralight materials with very high porosity and very low density. Those parameters gives the aerogels some appropriate properties to use in several industrial applications, such as the insulation for buildings and the construction sector. UCLM has produced some different types of aerogel during the last years. Talking about the organic aerogels, we can see that we have produced some polyvinyl alcohol and polyurethane-based ones. Alumina cellulose aerogels are included among the inorganic aerogels. All of these materials can be doped with different particles such as nanocarbon, nanoclays, or silica to improve their fireproof and mechanical properties, among others. The aerogels studied during this project are the polyurethane-based aerogels marked in red on the screen. We can offer some different characterization techniques for materials from both in and outside our installations. Talking about the morphological and physical characterizations, we can determine the density of some different materials. We can also determine the pore distribution and the pore size by using a mercury porosimeter. We can perform some scanning electron microscopy and some FTIRs to check the composition of the different materials that we analyze. If we talk about the mechanical characterization, we can offer some DMA analysis to check some different mechanical properties, such as the Young modulus, or we can also offer some DSC and TGA to check, for example, the glass transition temperature from many different polymers. Talking about the project, some low density and high performance biocomposite polyurethane aerogel panels will be produced by UCLM and validated by Action and Retols using mockups. These aerogels will be installed following the specifications and guidelines for thermal insulation biocomposite systems and will provide a new solution and a cost-effective reduction of the thermal insulation for older structures and for new structures, and the renovation of older ones. These aerogels have some other relevant applications besides the construction and the insulation for buildings, such as the automotive and the aerospatial sectors. In most of them, they are working as thermal insulators, but they can take another role, such as, for example, sound insulators. So that's all from my part. I hope you enjoy it. And if you have any question, please feel free to ask it.
So, thank you very much, Dario. So we are now moving forward to the next presentation, which will be Elliot from Composites Evolution.
Good afternoon, everyone. My name is Elliot Fleet. I'm from the UK. I represent a company called Composites Evolution. And we're a manufacturer and developer of thermoset prepregs. So typically some resin, effectively beta stage with some kind of textile. These are used by our customers to mould into shapes or to use with core materials such as the polyurethane foams that we've been mostly discussing today. And I'm going to talk about our pilot line, which has been made available through the BIOMAT testbed. In terms of expertise, we've got lots of know-how in the field of composite materials in general, expertise in the scale-up of thermoset prepregs, adjusting formulations of thermoset resins for these prepregs, which is included using nanomaterials and things like this in the past. We've got a strong background in natural reinforcements, particularly flax fibres, and on testing, characterization and demonstration with these materials. So that's my team there, with also my boss there, Brendan, Technical Director. We're a small company. I think there's about around 20 of us, turnover just under 2 million. We're quite agile, and we're able to do some sort of quite fast responsive R&D and work with some quite interesting niche markets. In terms of our pilot line, so there's a few things that we can do, and there's a few ways that we can work with other companies. Number one is essentially formulation assistance. We can work with quite small quantities of material and evaluate the suitability of such resins or additives for using as prepregs. So that might be adjusting formulations to give a suitable TG, get the right reactivity so that it cures at the right time, at the right temperature, and also has the right sort of tactile properties of the prepreg, the right amount of tack. If you want to stick it to a mould, you want it to stay on the mould, not sort of spring back or fall off until you've managed to make it. So that could be testing out resins that are supplied by clients. It could also be testing out additives that are supplied by clients. So there's quite a few different options that we can do. We've got quite limited dispersion facilities. So if you do need to disperse something difficult to disperse in a resin, like some of the nanomaterials, then you may need to also partner with another partner who has some expertise in that as well. The pilot line itself is pretty flexible, and it's a good proof of concept equipment for producing prepreg that's representative of a full production machine. So the main difference between the pilot line and the production line is essentially just the speed that we're running at. We run a lot slower, so we can run down to sort of 0.1, 0.2 meters per minute, whereas the production line could easily be running at 10 meters per minute, and you can waste a lot of money sort of throwing development materials down the production line. So it's flexible. We can make prepreg. We can also make bare film. You might want to do that if you wanted to make an adhesive or a surface layer, or we could add some kind of bare supports into the film. You can get results with, again, small quantities of material. On the pilot line, we can run narrow for maybe even 1 kilo of resin. We can get some useful results out of that. It's suitable for small production runs, which is good for demonstrator parts or sort of customer sampling, but when you don't want to sort of commit to a large-scale manufacture. In terms of testing them out, we have the ability to test the prepreg itself in terms of tack, outlife, verifying the cure cycle, or deriving the curing cycle even, and mechanically testing and characterizing the resultant composites. And we have the ability to make sort of small demonstrator parts that can show off the performance and the look of the materials that we've developed on the line. So this is just a quick schematic of what we do. So we start off with a release paper that goes through a heated section. On that you apply a resin, and the resin becomes drawn into a film on the paper. The fabric is brought into contact with the film. If you were making an adhesive film, you can completely skip the fabric part if you like. Top paper is applied, no other reason than to stop it sticking the machine together. It goes through a sort of heated section where it is sort of impregnated into the fabric, and in some cases the resin is partially reacted, which makes it have the right sort of level of tack. And the main difference between sort of this machine and the production line is simply that we would have extra heated stages so that we're able to run at a faster speed. It goes through a chiller, and it essentially gets wound up, and that is the product that we would then sell. Performance-wise, we can work from sort of A4 size pieces of fabric up to about 1.3 meters wide. Film weights from sort of 100 grams to maybe 800 grams roughly. And the resin filming temperature is sort of room temperature to about 80 degrees, but we prefer a sort of middle, sort of 40 to 60 degrees. In terms of sustainability, because it's a hot melt system rather than a solvent-based system, it's quite a lot lower energy use. There's very, very limited volatile organic emissions. We work a lot with bio-based resins and additives and natural fiber textiles. And how we're using it within the BIOMAT project, we are developing, evaluating and upscaling bio-epoxy prepreg and other bio-based resin systems and additives. We're using the line to test out other pilot outputs, such as the non-woven fabrics being developed by HSK, and the prepregs themselves are being used with the foams that have been developed within the project. So there's quite a few different links there. In terms of other relevant applications, I think prepregs are generally sort of fairly industry sort of agnostic. There's application throughout automotive, motorsports, aerospace, space, sporting goods, mass transport, energy. Generally anything where sort of weight is a premium is usually has a good outlet for prepregs. That's the end of my presentation. Thank you.
Thank you very much, Elliot. So we are now moving. We are now moving to another pilot presentation from IBW. I would like to ask Bernard. You're here, Bern, to make the presentation. I think no. Sorry. IBW here. Do you have videos? No. Okay. Please. Okay.
So, okay. Welcome. So, my name is Bernd Wetzel. We have a pilot line at IBW which is concerned with the development and manufacturing of nanofilled polyol and resin formulation, so compounding. I'm from the Leibniz Institute for Verbundwerkstoffe, Leibniz Institute for Composite Materials, IBW. We are located at Kaiserslautern, which is in southwestern part of Germany, 150 kilometers southwest of Frankfurt, Maine. So I'm head of the material science at IBW, and actually IBW's mission is to develop polymer composites from fiber reinforced polymer composites, especially starting from chemistry in the lab up to the part, up to the application, along the whole value and processing chain. And in this project, we have an interdisciplinary group involved. We have chemists there, we have material scientists there, mechanical engineers and all technical stuff. And we have 20 years of experience in nanocomposites formulation and development and their application. And our aim is to generate bio-based polymer nanocomposites in this, and here we have the product line for, and the pilot line for. Oh, that's okay. Great. And here's a scheme of the pilot line, actually, which has a modular setup, and it's absolutely flexible. And our aim is to disperse any nano fillers or microfillers in a liquid media. So we have 4 devices here independently but modular, so we can combine them also. And we have devices here for inline and at-line monitoring of the quality of the system and the information on the processing and efficiency in dispersion of the process. And so if we start here, we have a a system where we can make master batches in small amounts, so use modified nanofillers in polyolefin resin, so we can add this also, we can add other surfactants here in an ultrasound line, and this can be introduced then into a special wetting line where we can add also powdery fillers in larger amount. So we can feed in up to 50 kilos per minute of powdery nanofillers, and this can be used here in the final dispersion step in a large dissolver, which can produce up to 200 kilos batch. And finally, we have a nanocomposite polyose resin formulation for foams or for composites. So for composites evolution, for example, they will apply this for prepregs. And from the measurements line, we get the information on the quality of the system and the dispersion process. We measure rheological properties, viscosity. We get information on the particle size online and inline. So let's go into details. And here's the first module, the 3-roll mill. It's computer-controlled process here, and we monitor all the parameters. We have high shear forces applied for dispersion of the fillers. The rollers are made from silicon carbide. This is an older version here, but it's gray actually, so it's very wear resistant. And we use this system for small amounts of resin. We create master batches that can be used later on to be filled in the final formulation. So it's good for high viscosity formulations where we have maybe a large amount of fillers involved, and especially for more sensitive materials such as carbon nanomaterials, graphene or carbon nanotubes. And so this allows also to prepare storage stable, high concentrated batches of nanofilled formulations on request. So the second module is an ultrasonic line, so high performance flow cell actually, a reactor. So we can use it in batch-wise process or continuously to disperse the fillers in the liquids. And we have at the same time during the process a degassing, of course. The amount is relatively small compared to the other modules, 2 liters net. And it works for a lower concentration of nanofillers, but especially for those which are maybe more sensitive to any shear forces. So the third module is an Austral pilot tech plant. So here we have a powder suction into the liquid resin directly. And this is completely dust free and loss free. So we have no material loss. So it's, the powder can be fed up to 50 kilograms per minute here. And there's in one step a wetting, an inline mixing, and also a wet milling of the powder in the resin and the dispersion. So this is good for medium viscosity products. So we have a power of 4 kilowatt and have high shear forces due to this rotor-stator system to break up any nanoparticle agglomerates in the powder. So the throughput is up to 40 cubic meters per hour, and we can make up to 70 liters of product here in this step. And this can be fed actually into this device, which is a fourth module. It's a dissolver. So we use now in this case a teeth-wested disc here, which applies high shear forces during rotation. And we break up nanoparticle agglomerates in this case and disperse the primary particles in the resin, in the polyols or the epoxy, for example. We apply vacuum we can apply vacuum during these processes to remove any entrapped air, degassing, and we control all the relevant parameters in a loop. So we measure the torque here directly inline, so we have a torque sensor attached to the shaft, giving us feedback on the torque, which is directly related to shear forces applied to the mixture. We measure speed, net power input, and temperature, pressure, and especially the particle size developing during the process, because we have an inline optical sensor that allows or gives directly feedback on the particle size developing during the process. So power is 11 kilowatt, the speed up to 3000 RPM, and the maximum torque is 72 Newton meter applied, and here we can work with batches up to 200 kilograms. So finally, performance is that we get high quality dispersions of fillers, micro or nano, to get functional polymers, multifunctional polymers. It's quite important because adding different kinds of fillers is of course also possible, and you can create various properties by combining them. We have the inline quality control during the process and optimization of the process parameters. And in this project, of course, we work with bio-based sustainable systems, resins and additives and also fillers, and we optimize the processing cycles. And well, these are applied in foams or composites, yeah, but not only. So we have already applied such systems, and we still apply them in other applications, like here a CFRP car wheel, here in aeronautics, or here wind turbine plates. Currently activities in hydrogen pressure vessels, or here in flywheels, and this process can apply to make materials for such applications also. So it's not restricted basically from the technology. You make liquid mixtures and compounds for foams, for resins, coatings, adhesives, and composites for mobility applications, energy, also health maybe, production. So there's not much restrictions, depends on the functionality of the final system. So thank you for attending. If you have questions, please feel free.
So thank you very much, Bernard, for the presentation. We are sorry for not allowing, being allowing this discussion between the public and the services, but we have a lot of different presentations to do, and we do believe it's better to present all the opportunities you have, all the equipments, all the materials, all the different types of materials you can develop and then use and apply in your products, then discuss it. At this moment, for sure, again, I would like to highlight it, we'll be more than happy to answer all of your questions after the workshop, by email, by face-to-face meetings, or in other ways. So now I would like to call to the stage our colleague Amit Eger from Melodea. If you can present your ballot, please.
Just a question. Will we get access to these presentations?
Yes.
Later?
Yes. The idea is to provide you. Of course, we will need to check with some partners yet, because some of them were just received in the beginning of the workshop, so we'll need to talk with them, but for sure we will make sure that all the information we are providing here, considering it's a public event, for sure you will have access to it. Okay? Okay, so please, if you want to have here the pointer, the moving of the slides is not working, so you should.
Oh, okay.
Okay, thank you very much.
So, hi everyone, my name is Amit and I am a researcher in Melodea from Israel. I will present Melodea and the pilot production of modified CNC or MCNC that we develop in the BIOMAT project. Cellulose nanocrystal are the natural building block of all the planets on Earth. They show great performance in various applications. and they are excellent for production of novel eco-friendly materials. About the CNC production, controlled acid hydrolysis of cellulose leads to degradation of the amorphous region of the cellulose and to the release of the crystal termed CNC. As shown here, produced CNC in water suspension or gel form, the crystal have a rod-like structure, and when they dry, they can form very nice transparent film with very interesting properties. Melodia has a pilot production capabilities for CNC. The plant is in south of Israel. We use 200 liter and 1600 liter reactors. The plant is fully equipped for purification and dispersion of the CNC. We also have a full QC and QA for the process and the product. CNC can be utilized in different applications, such as barrier packing, film and composites, and a variety of other applications. As part of BIOMAT project, Melodia develops and produced modified CNC. We develop chemical reaction to change the surface of the crystals from hydrophilic to hydrophobic. We have reached a pilot scale production of modified CNC. The MCNC is a powder form. The expected production capacity is 1 to 5 kilo per batch. We perform full evaluation and characterization of the product. We can develop different modifications for different products. MCNC can be utilized as additive in composite materials. Different modifications allow compatibility with different systems. MCNC addition can change properties such as mechanical, thermal, and more. In BIOMAT, MCNC is used as an additive for improvement of bio-based polyurethane form. Thank you very much for listening.
So thank you very much, Amit. We'll just change here one presentation because our colleague needs to go to the airport. Again, sorry for the delay. Now we'll have Georg Werner from Fraunhofer, and he will present the pilot line number. This presentation, correct? It's this one.
Open? No, because no.
I think it's that one. You changed it.
Yes.
Okay, perfect.
Thank you very much.
That's okay. Oops, sorry.
Good afternoon, everybody. My name is Georg Werner, representing today the pilot plant in Skopje. So this is a joint initiative of the Fraunhofer Institute of Applied Polymer Research and the Institute of Microstructure of Materials and Systems. With budget of about 4 million per year and with almost 40 employees. So we are settled in Skopje. This is the heart of Germany and the heart of the Europe, with a very long tradition. It's the first rubber, the first industrially synthesized rubber was in this place. So what can we do? This is we make solution polymerization. It means synthesis of rubbers and polysulfones, heterophase polymerization, polycondensation. It means polyesters and polyamides, and continuous line hydrogenations and NIDA technology. NIDA technology means rubber synthesis and polyester, for example. We have line with main reactors between 50 and 1,250 liters, with suitable infrastructure, with its safety, with waste gas combustion, and with water treatment, fully registered by German and European authorities. Our main competence is scale up, but we make also the scale down. Okay, I will explain this. Everybody knows what about the scale up, but scale down is sometimes important. So, if we contract with our client, some things are very important. Firstly, the chemistry has to be fixed, and typically the one project lasts between 2 weeks and 1 month. So the client gets from us the scale-up product, and knowledge is about equipment and realization in the pilot plant as all. So you can imagine this is not every time that simple, but the man says we had some small problems with scale up. So here a small example from our work. One plant had issue with polymerization in a NIDA of 1,000 liters. For the study of this, it had to be scaled down to 10 liters. This is the small discs reactor for the study of kinetics and other questions. And after this, we could scale up the reaction to the 1,000 liter discs reactor for the synthesis of polyester. So the client was happy, and it's like every time. Okay. Thank you very much.
Questions will be sent to you if we have some issues, okay?
Yeah.
Thank you. So thank you very much. Now I would like to invite Laura Boghini from National Research Council of Italy to join us. It should be this presentation, correct?
Yes,
Just to confirm, is this one correct?
Yes.
Okay. If you want, you can use here the pointer.
No.
This way.
So, good morning to everybody. My name is Laura Boggioni. My company is CNR, the National Research Council of Italy, and we are responsible for pilot number 8 on biopolyol grafted bio-nanofillers. In particular, my institute is the Chemical Science and Technology Institute and is located in Milan and is one of the 100 institutes of CNR in Italy. And SciTech carries out both basic and applied research in the field of the molecular science. The many topics, research topics of SciTech are heritage science, advanced material, green chemistry and sustainability, chemistry for life science, and chemistry and energy. We are equipped with laboratory with modern instruments relevant to the process of research, innovation, and control in all fields of chemistry and material science. And concerning pilot number 8, on the polyol grafted bio-nanofiller, we have set up 2 protocols for the functionalization of the filler in suspension and 1 protocol for the functionalization of the filler in powder. For the suspension, we have used the crystalline nanocellulose provided by Melodea, and for the filler in powder, we have used the calcinated silica from rice husk provided by Senti. Here is show the description of the functionalization of filler in suspension. It consists of 4 steps. We have used the crystalline nanocellulose of Melodea, is provided in water solution. So the first step is the freeze drying of the cellulose. Then the filler coupling, and we dissolve the CNC in DMI solvents in dry condition, in inert atmosphere, and in the presence of lithium chloride. The temperature and the condition are mild, and then we add biopolyol and the silyl as a linker with the base catalyst. Then there is a step of washing to remove all the unreacted polyol, and we use a Soxhlet process. And then we keep all the functionalized nanocellulose for 1 night in the oven to remove all the solvent presence. Concerning the silica provided by Senti, it consists in 6 steps. The first and the main steps is the activation of the silica in the presence of sodium hydroxide in water solution. And the second step is the acidification of this solution. Then we have to remove all the water presence in the sodium hydroxide. So we kept the silica for 1 night in the oven in vacuum at 80 degrees. Then there is the step of the filler coupling. But before the filler coupling, we have to react the biopolyol with the silane and in presence of DAPCO in DMA and inert atmosphere for 24 hours. Then the addition of activated silica, and then the silica is functionalized and is washed by using, in this case, a centrifuge to remove the unreacted polyol. And also in this case, we dry all the functionalized silica in the oven for 1 night in vacuum at 80 degrees. Concerning the pilot production and characteristic, we can graft on the CNC 40 weight polyols, 4 grams of product, and concerning the silica, 25% of polyol, 4 grams of product. The pilot performance goes from 400 grams batch to 1 kilo batch, and 4 weeks and 2 persons are necessary. And concerning sustainability, the fillers that we use are from renewables, And in the case of the CO2 grafting, is necessary a very low amount of solvents. Here are the picture of some of the equipments, some of which have been both with the BIOMAT founds in 22. We have freeze drying, a big centrifuge, and reactor that goes from 6 liters to 10 liters, and of course TGA and FTRR for the characterization of the final product. That's all for my side. Thank you.
So thank you very much, Laura. I would invite now Silvio Perez from UPC to present.
Hi all, I'm Silvia Pérez Rafael from Universitat Politècnica de Catalunya, and today I will present Pilot 9 and Pilot 10 in BIOMAT devoted to non-enzymatic production of lignocellulosic adhesives and or internal adhesion promoters. So in this project we implement our knowledge in sonochemistry, enzymatic reactions, functionalization and nanoparticles preparation to functionalize raw materials for its incorporation in different bio-based formulations. So starting with Pilot 9, it consists in a 3 liters capacity bioreactor with 3 blades and a control unit to data recording, calibration and programming. We are also able to control the pH, the oxygen, and temperature. Within this pilot, we functionalize lignocellulosic raw materials to coupling natural phenolic compounds via enzymatic reaction. Following the BIOMAT philosophy, this is an environmentally friendly process using a fast catalytic reaction in water, non-toxic substrates, and the residues and the byproducts are natural compounds that can even reused. Pilot 9 configuration consists in a high volume flow cell ultrasonic reactor coupled with a peristaltic pump that let us to work in a continuous flow and process up to 100 liters per hour. Using this pilot, we produce lignocellulosic nanoparticles for its incorporation in different bio-based products as fillers to enhance the mechanical properties and impart new functionalities to the final products. We also use non-toxic substrates, and again, the residues are natural compounds that can be reused. Both Pilot 9 products can be supplied in purified form and powder using a semi-industrial centrifuge and freeze dye that we have installed in our facilities. So as a summary, applying these environmentally friendly procedures, we produce, functionalize, and nanotransform lignocellulosic products for incorporation in different bio-based formulations. But we also offer to BIOMAT partners and open tender clients the functionalization and nanotransformation of different raw materials, as for example hemp, linseed, and sunflower powder, and also the modification of cork. With desired properties, because we can impart antibacterial, antifungal properties, UV resistance, and even hydrophobicity. As a summary, the main products that we can provide are phenylated lignin and lignin-derived nanoparticles with enhanced reactivity, adhesive properties, and better compatibility with different polymeric formulations to produce foams, resins, adhesive, and sandwich structures. We also identify other application of Pilot 9, Pilot 10, other processes that may are of your interest to implement. For example, versatile green methods for biomass or polymer modification, and also the upscaling in sonochemistry, the preparation of different nanoparticles. So that's all. Here you have our contact, and thank you for your attention.
So thank you very much, Sylvia. Now we will need to make here a small change because unfortunately airplanes are not waiting for us yet. So we are asking Stefania to join us and present, Massimo to join us and present one of the horizontal services that should be presented during the afternoon, but we'll move it to this morning, let's say, afternoon. Is this one correct? Slides is, yeah, this one. Okay, it's Stefania, but you have the pointer here.
Hi everybody, I'm not Stefania Truffo. Most of you already know me. I'm Massimo Perucca. I mean, we are from the same team, Project Hub 360, partner of BIOMAT Project. So it's a challenging talk here before lunch. I try to be very short and getting to the point. Thank you for your attention and your resistance. So, yeah, just to move slides. Yeah. Okay, so we are now talking about services. So far we have seen very nice processes, materials, and bio-based materials, solutions for the industrial manufacturing world. Now we are talking about services related to business development, plan development, life cycle assessment, costing, social life cycle assessment, and IP management, IPR management. Okay, related to the business plans that are implied in the innovation getting to the market, we are offering different activities like analysis for support and industrialization and commercialization of the new processes based on quantitative methods, on measurements, on of course impacts and potential revenues, costs, and also processing costs and all costs incurred in different activities from top to down along the pipeline of the innovation implementation. Qualitative and quantitative market analysis, commercial strategy, which is of course developed jointly with the companies, also related to the governance and vision of the company in terms of new processes, new products, and innovation. Then economic study and communication plan for promoting the innovation. Let's of course skip this slide and get to the life cycle assessment and life cycle costing, which are enabling somehow the business plan to get into the market activities. Because what we promote is the quantitative approach. So we have to measure. We state and we claim to be sustainable. Sustainability means low environmental impact. We learned that the market is not so ready or not so keen in paying more for sustainable products. So sustainability means also low cost, sustainable cost for the company. And LCC is dealing with this topic. So analysis of costing from A to Z in a process for implementation, innovation, and production. What is life cycle assessment about? This is for about environmental assessment of impacts, and those impacts have different say, dimensions on the environment. We may talk about CO2 or acidification of waters, eutrophication of marine waters and whatever. So we have to compare solutions in order to get a clear view, a clear profile of what could be the improvement in products with reference to a circular framework. So what could be really less impacting on environment and still sustainable under the costing point of view. So this is what LCA addresses, and it's ISO standardized procedure. So the ISO standards are ISO 14040 and 44. It's recognized, it's based on acknowledged international databases and provides really the measurement of CO2 outputs, of acidification potential and eutrophication potential. Those are, just to show you, some of the main impact potential categories addressed by the LCA, and all the effects that are pictorially referred here as environmental impacts. And I want to also stress the point that the LCA is not just dealing with the environment as it is, because it has an holistic view, and we are part of the environment and as humans, so we also have the human toxicity potential, not only the environmental soil, water, and air, toxicity. So, that's the general perspective of life cycle assessment, and we are pointing to circularity. So we are talking about recyclability of pollutants and bio-based materials, the sourcing of the materials to the technosphere, the transformation processes from the environment, and all these steps in the life cycle assessment are addressed and measured. So that's the important point. For life cycle costing, it's quite important. I mean, the life cycle costing is based on the same framework, even if it is not standardized. It is for building and construction sector, but not for all other sectors. So we are just referring to best practices and do best available indications on how to deal with this. But basically, it's based on LCA framework. And still it's of course based on quantitative analysis, but still what we address as cost, and this was one of the topic in yesterday's presentations, is not just the processing or production costs or manufacturing costs. There are also other hidden costs when we want to get to the market and to be competitive, and this has to be taken into account. Last but not least, the disposal. Okay, so we have some environmental costs that have to be taken into account, and given this, we can really prove that bio-based materials and recyclable materials may play a role in terms of competitiveness for the industrial world. Okay, just skip this. It's about social life cycle assessment, which can be, of course, included in a top-down approach, so providing indicators of the choices of materials and the supply chain, for instance, that are implying some social and impact indicators like fair labor, gender issues, and they will have also impacts related to the regionalized analysis in terms of added value. It's important to say that the life cycle assessment is really a project by itself, so analysis needs data collection, pre-processing, meeting, and first interpretations, and of course it's very important to have a vision for the possible scenarios that could be addressed in order to really implement improvement in processes and products and new materials. Also addressed to specific applications, because the concept in which is, the pivotal concept of life cycle assessment is functional unit. So if you are really able to define a functional unit of a product, it's not just the material itself, it's the functionality that we are going to sell. And based on comparative analysis of the functionalities, you will get the right environmental impacts and the right costs that are associated with this. Okay, this of course needs what-if analysis and a comparative approach, and this will be, will be enabling factor to decide also on the governance processes of the companies, to say, okay, that's the direction, that's the critical point, that's the vision we have, that's the big opportunity that we could exploit to be competitive and to win the competition. Okay, IP management, of course, if we want to get to the market and to have a good business plan, we have to check the freedom to operate, because if other materials processes are already patented or protected in terms of IPR, we cannot sell, we cannot commercialize, we cannot produce, and this is a really important point to be done in parallel with business plans and with sustainability, because a product is sustainable if you can sell it as first. So let's also now analyze the IPR by patent search, by getting in touch with experts and technical people, and also to define potential claims in order to protect your innovation as a counterpart to defend yourself in a global market, which is just not a trivial stuff, but still it's a very important point, milestone in the process for innovation. That's all we can propose and offer you. Of course, everything is connected to environmental social governance, so we also are, it's not included in the presentation, but it's part of our expertise in helping companies to get their sustainability rating, which is part basically of the innovation, sustainable innovation process we are addressing in BIOMAT. Thank you so much and have a good lunch.
Thank you very much, Massimo. So now, before going to the next presentations, just to inform you that we'll move 3 presentations from the morning to the afternoon, just to make sure that everyone is full of energy during the afternoon. So we'll have the lunch in some minutes. Before going to lunch, I would like to ask you to, if you need a taxi for this afternoon to go to the airport, just ask my colleague, Filipa. She is taking care of it, so please do it. And well, for the partners that were yesterday in the meeting and didn't gave us the badges, the identification badges, just a reminder, please do it to make sure that in the next meeting we'll use the same. We need to reuse the materials that we are buying. That circularity, that's it. And sustainability as well. So thank you very much for your attention. It was a very long morning, so we intend to be back in 1 hour and 15 minutes, so maybe at 3 o'clock. So please try to be here at that time in order to do not delay more the workshops, okay? For persons that are attending online, we'll be back at 3 o'clock Portuguese time, okay? Yes. Yes, you can leave your things in the room, because the room will be closed, okay? Sorry, the lunch will be served in the same place where you had the lunch break, okay? It's time to go back to the presentations. I hope you have enjoyed your lunchtime and you had the opportunity to discuss some possible collaborations under the BIOMAT services. We intend to start again with the presentation of the pilots because we still have 3 to present, and then we'll move to the horizontal services. So I would like to ask now our colleague from Senti to join us now to present Senti pilot line. So Marcelo, please.
Good afternoon. My name is Marcelo. I'm from Senti's team. Wrong PowerPoint.
Sorry, my mistake. Sorry.
So I will present our pilot line for the production of hydrophobic, flame retardant, antifungal or antimicrobial biosilica nanoparticles. First, let me introduce Senti. Senti is a private non-profit R&D center. We are located in Vila Nova Famalicão, as you know. Pilot lines are very important to us. We believe that the interaction between R&D centers and industrial companies is very important to not let innovation and to not let innovation only happen in the laboratory scale, but to find a market to our products and our innovation. So in the previous projects, and especially with BIOMAT, we have increased our knowledge on valorization of industrial residues and also on nanoparticle synthesis. So our pilot can be divided into parts to process. The first one is the extraction of silica particles from agro residues. And the other one is the modification of the same silica to impart different properties. We have established a KPI of maximum production of 300 grams per batch. So our process starts with our reactors. We started this study in conventional glassware, but we have successfully scaled up our silica extraction up to 500 grams per batch in our stainless steel reactors. We have one of 1 liter and another one of 600 liters. For the functionalization of silica, it's a more challenging reaction, and we produce 300 grams per batch in our 10-liter glass reactor. Another key equipment is the high temperature oven. Its job is to eliminate the remaining organic compounds from the silica. It has a volume of 216 liters. This is a separation equipment used for the separation of nanoparticles after functionalization. It has a volume of 6 liters and a maximum gravitic force of 30,000 Gs. This is the newest addition to the family, although the delivery is still pending. It's a vibratory sieve to separate the agro residues from the silica extraction. So apart from the production equipment, we also have product characterization equipment. We make many tests such as FTIR, TGA, OVV-SNIR, DLES, SEM, antimicrobial, contact angle measurement, and flame retardancy. We make these tests to know that none of the changes that we make in the process affect or compromise the quality of our product, and to know that the very end product respects and fulfills the requirement of our partners. So this is the most important slide. Senti's work in the BIOMAT Open Tender will be the production of silica from bio-based residues with different functionalities, such as hydrophobicity to prevent water absorption, flame retardancy to prevent flame progression, and also antifungal and antimicrobial properties to stop the growth of harmful bacteria, for example. The application is as fillers to foams in sectors such as automotive, construction, and home textiles, bedding, and so on. Thank you for your attention. If you have any question, please ask. Thank you.
So, thank you. Thank you, Marcel. So now it's time to move to another pilot line, which will be presented by Andrea from AEP.
Thank you, Antonio. Good afternoon to everybody. My name is Andrea Miniger. I am one of the co-founders of AP Polymers back in 2013. AP is an independent private SME dedicated to industrial R&D in the field of polyurethanes, of composites, coatings, and adhesives. With this short presentation, I want to complement the presentation of Fraunhofer Institute, Fraunhofer EAP, regarding the polymerization plant. In fact, in some way, inside the pilot 11, if Fraunhofer EAP is a sort of the hardware, so the big pot and the big competence to make big reaction that reaction on the bigger scale. The role of AP in not only in reinvent but also in let's say in private consulting works is the development of new bio-based polyols. So our expertise is a blend of organic chemistry which can be applied both on petro-based and bio-based molecules and polymer science. One of our main activities is to design and develop bio-based products, in this case biopolyols, and to do the first upscaling up to 5 liters reactor, which is enough to optimize and then transfer a recipe, or the SOP as we call it. Our focus is on process scalability, so we try to do our best to make the process easily scalable. The cost, of course, the performance of the biopolyols, and then sustainability and REACH compliance, which is critical if you don't want to spend time and money in the process, in the registration process. We take care, of course, also of the freedom to operate analysis, so we try to avoid developments which are already covered by IPR of third parties. And the first thing we do with the biopolyols that we develop is to assess their performance, their usability inside foams. So we are not formulators, but we play a little bit with foams to ensure that our polyols can work. And as a side, let's say, work in the bio-based economy, we can also perform usability assessment of bio-based materials. So this is just a quick overview of some of the equipment we have. So we stop at TRL 4 to 5, so we are on the lab scale, but on the scale which is enough to provide, for example, sampling to partners and to optimize the production protocols. And in terms of main characteristics of our biopolyols in BIOMAT, but also in outside, they can be obtained from both plant oils, but also from lignin for different applications, both rigid and flexible foams. One advantage is performance. So the compatibility with the standard raw material, blowing agent, but also other types of other families of polyols. We can cover a wide range of reactivity, playing with the chemistry, the chemical modification on the substrate. The same is true for the properties, and those polyols can be used to significantly increase the bio-based content of the formulation without detrimental effect on the foam's property. It's an experience that we are now spending in BIOMAT, but we work every day also for industries. Although we don't go into production as AP, several of our biopolyols are now in commerce under the production of Cardolite Corporation. And of course, the other advantage is the sustainability. We have developed bio-based polyol with bio-based content up to 88%, and a good, let's say, average replacement in standard formulation is around 40%, which is already a very good contribution to, let's say, to developing new bio-based formulation. Thank you very much indeed for your attention.
Thank you very much, Andrea. So now it's time to move to the last presentation about the technical pilot lines of our project. Lutz from Fraunhofer will do it. Just this one. This one.
Thank you very much. Yeah, good afternoon also from my side. My name is Lutz Hartmann, and I'm going to present the pilot, which is entitled Microwave-Assisted Chemical and Chemoenzymatic Recycling of bio-PUR based composites. I'm speaking for the Institute, for the Fraunhofer Institute for Applied Polymer Research, and basically I'm representing its sub-department for polymeric materials and composites, in short, PICO. The key competences of PICO, or the main focus of our research activities, lies in the development of composite materials, especially of fiber-reinforced plastics with thermosetting polymers as the matrix material. In this process, we cover the complete value chain. So we start typically with the monomer, which we can modify chemically to determine the properties of later products, and we end up this chain with the manufacturing of parts or prototypes by various techniques. One focus lies also on the investigation of alternative curing methods. So here we have already the microwave, which is involved in our pilot, but curing by UV light, IR light, or electron beam are other activities. We have all necessary characterization competences available to characterize the state of our development along this mentioned value chain. And finally, the issue of recycling and reuse plays also an important role. So the combination of the microwave and the recycling reuse is just the subject of our pilot. One main facility we employ in this pilot is this industrial large-scale, this industrial high-volume microwave furnace with the name Hephaestus. It is basically not so much different to a household microwave, but there are, of course, also some obvious differences. One is the volume, which is about 8 cubic meters, allowing, of course, to process a much larger amount of material at the same time. We use, we have here a hexagonal cross-section, and in combination with in total 36 magnetrons, we are able to illuminate the whole volume with the electromagnetic radiation. And another difference to a household microwave is that we have installed various sensors to measure the temperature, and this allows us to get a closed loop, so we can define a temperature set point for the material to be processed, and the microwave power then will automatically adjust it to meet this temperature set point. The goal in BIOMAT is to use or to establish a microwave-assisted boilant of polymer, in our case of PUR foams, in a certain recycling agent under reflux conditions. This aims finally at an energy-efficient microwave-assisted decomposition. Why energy efficient? The advantage of the microwave compared to other curing techniques is that we selectively heat up only the matter which we need to heat up. And since the mixture of the polymer and the recycling agent is stored in a glass reactor typically, this reactor ensures thermal insulation, so the heat once generated is or loss of the heat once generated is prevented by the thermal insulation provided by the reactor. Another point we are currently still investigating is the possible combination of the chemical decomposition with an enzymatic pretreatment, but this is, so to say, still ongoing work. And as shown here on the left, the progress of degradation is typically characterized by IR spectroscopy and viscosity measurements. So presently we have already successfully set up this pilot on a small scale, so we are able, which might be interesting, for instance, for pretests, where we have to consider only smaller amounts of matter. So up to 3 liter in a single reactor, or also the combination of 2 smaller reactors has been tested. We have already successfully decomposed PUR foams by so far glycolysis and aminolysis. But the final goal, which we are currently also working on, and we hope that we will finish till the end of February, the final goal is to scale up the previous slide, so to say, to first to a single 30-liter reactor. This should be finally placed here below a rack we have already constructed, and the rack serves as a holder for a pneumatically driven motor, which has to be mounted on top of the reactor. And a homemade stirrer at the end will be connected to the motor, enabling us to stir the material to be recycled. And here the thin blue cylinder finally is the reflux condenser, which we need, of course, for the boiling under reflux conditions. Yeah, the prerequisites we have, we ideally to optimize the process, we should know as good as possible the formulations of the material to be decomposed. In general, also we should discuss in advance the potential recycling agents, especially also for other polymers than PUR foams. So the main question is, are they microwave absorbing? And with this knowledge, we then could, prior to the experiments, could already optimize the decomposition. Yeah, related to the sustainability, I have already mentioned the selectivity of the microwave assisted heating. It is selectively, it is rather fast, and since we prevent thermal loss intrinsically by the reactor walls, we expect the whole process to be energy efficient compared to reference processes. but of course any quantitative energy balance has to be calculated for any specific application. Yeah, the outcome we expect are, of course, the trivial one is the decomposed foam, which we could try to reuse without further treatment in new formulations of new materials. And the second approach after the decomposition might be to try to purify and to separate the recyclate into, or to separate at least single components such as the polyols from the recyclate. And at the end, I would like to point out, since we are dealing with microwave heating, I would like to point out to some other potential applications beyond BIOMAT. So we can think of standard applications such as tempering, drying, or curing, and maybe more interesting could be that we are, by the use of appropriate microwave susceptors, we are able to create rather high, at least in a small volume, we are able to create rather high temperatures around 1000 to 1200 degrees Celsius, which, for instance, enables us to cure or to burn clay, such as it is shown here for the example of such a cup. And another, maybe not standard application is also that we could apply the microwave oven for the sintering of printed conductive inks, so to end up with printed electronics, especially on temperature-sensitive materials. So that's it from my side. I thank you for your attention.
So thank you very much, Lutz, for the overview about your pilot line. So now it's time to move to other type of services that we are also providing under the BIOMAT project, which we called as our horizontal services. You saw in the morning already one presentation from Project Hub. We also have other partners providing other types of services which are not technical ones. So we are now, and the idea of the project is also to try to couple this or to join these services with the services that, with the technical services that we are providing under the pilot lines. So unfortunately, our colleagues from ITG were not able to join us today, but they kindly provide us a video, a 5 minutes video, in which they will present.
First of all, thank you so much for
their
the
pilot,
invitation.
their services and what they are also doing in the project. So please try to pay attention. It's a video, but they are able to provide any answer afterwards.
For the invitation. My name is Oscar Brandon, and now I will talk you about the digital twin, which is a business support service within all the diverse services offered by BIOMAT. The digital twin service is provided by ITG. So firstly, I want to tell you a little bit more about us. Well, ITG stands for Instituto Tecnológico de Galicia. We are a private non-profit research and development center recognized as a national technology center by the Ministry of Science and Innovation of Spain. And we are located in A Coruña, in Galicia. As you can see at the right side of the slide, we have several areas of knowledge, and related to BIOMAT, all our expertise around the Industry 4.0 is key. And within BIOMAT, we develop the digital twin. So, what is the digital twin platform? In summary, it is a tool available at 12 pilot lines as a service. that supports the following topics. First, with regard to monitoring, it allows basically to connect all the data from the manufacturing process in an orderly manner. This enables to set up the basis to monitor, control, and model the production processes. Basically, we connect the data to the platform. Once we have the data within the platform, we can extract value from it. So, capitalizing on the existing information, BIOMAT includes tools that provide models, for example, based on artificial intelligence or hybrid techniques. Then, once we have the models, the BIOMAT-TB platform supplies with tools that we have called what-if tools. And why are they helpful? They are intended to explore scenarios virtually before manufacturing, so it saves time and money. We can assess what happens if we change some parameter or material of the process, and we can see, assess, as I say, the effects on the final properties of the product. And what's more, we can explore the optimization of the processes to achieve certain target values for the product parameters. And finally, as we want to encourage you to find suitable bio-based products for your existing needs or potential, the digital twin assists you in identifying which BIOMAT products might be suitable replacements for your current applications. And going into the detail of its core tools, we have three main blocks. As you can see in the slide, we have the data acquisition and traceability, the DTP toolbox, and the products recommender. First, the data acquisition and traceability deals with data management from sensors, equipment, and so on. And moreover, it includes the traceability, which means the data leveling across all the different batches, both internal or external, that are involved in the production process. Then we have the DTP toolbox, which includes mainly the pilot viewer to view data in context, the simulation manager to manage and use models like the ones that I've mentioned before, and the production dashboard to control the key performance indicators and the control process parameters at the line, at the testbed line. Finally, the products recommender that provides a catalog of produced products and a tool to support decision making when looking for substitutes for commercial products within the available BIOMAT products. So that's all with regard to the digital twin service. Thank you so much for your attention.
So Oscar from ITG was not able to join us today, but he is fully available to discuss any question or any doubt you have about this service that will be offered, I would say, together with the technical services. It will also be available during the open tender. So now we are moving forward to another service provided by Università Milano Bicocca. We'll have our colleague Rosella. She is attending, sorry, I forgot to, she is attending the meeting via Teams, so she will try to make the presentation in a virtual way. So, Rosella, just checking if you can hear us well.
Yes, good up.
Perfect. I will just put you on the wall. We're trying to put you on the wall. Okay. So, Rosella, everyone is looking at you. So, as you wish, you can start and also sharing the presentation.
Okay, I will share my presentation. Sorry. Sorry, having some problem with the... I don't know why it's not working. Can you hear me? No. I don't know why I'm sharing screen. Okay, now it's working. Okay, good. Okay. Thank you for your patience. Good afternoon, everybody. I'm Rostella Bengalli from the University of Milano, and I do now the service in the BIOMAT project, that is the nano safety and toxicity. So let's see. Yes? No problem. It's better to see the presentation instead. You're welcome. So, brief presentation. MIB, the University of America, was born in 1990, located in Milan, so it's a young university. It turns 25 years old this year, but is highly active and expert in many research fields with projects and teaching activities that are applied in several research areas such as physics, chemistry, biology, environmental, economics, statistics, psychology, medicine and surgery, and educational science. In the BIOMAT project, we provide a service, the evaluation of nanosafety and toxicity. We have heard today that one goal is to provide sustainable in the BIOMAT also for the future. But you will hear in the future the European Commission, and that is also oriented on the safety of these materials, of these new innovative materials, bio-based PUR forms, and also composites. All our service is evaluation of bio and exposure, and the safety and hazard of by an environmental point of view, also for humans. In detail what UNIMED can provide in the field of nanomaterial release and exposure. We perform leaching tests, so I don't know if you can see the pointer, so bio-PUR forms, but also other substrates, polymeric substrates such as textile or water depuration membrane, something that is also based from polymer or plastic, can be used for leaching tests, so under control and with the protocol that are validated in our lab, can be produced the leachate that are characterized with the instruments such as ICPOS, SEM, so electron microscopy, and DLS, and then the leachate can be exposed to zebrafish embryos that are for the production of and other compounds. And it's a feature of our zebrafish facility at UNIMED. So it is possible with this test to compare the toxicity or safety, we hope, of different compounds that are in bio-PUR forms. Another service that we provide is the evaluation of the air release and human with field monitoring campaigns. So the evaluation of the release both in the air. So with this solution, a light pack with the monitoring of fine and ultra-fine particle matter concentration with and particles that are some instruments that could be used for force monitoring, and increase the complexity in other instruments for the complete measurement of the airborne nanoparticle, coupling the in modeling. So you can find an example. So a pain of the release part production of synthesis, so also during manufacturing line 1, the one CNR monitoring campaign that we perform, the particle number concentration is collected and used for lung deposition in modeling. We are able also to calculate environmental realities that for in vitro exposure under lab control conditions. Can also have the physical chemical properties of the release at occupational sites with the with the human effects, health effects. We also provide toxicity assay for the human safety. We perform toxicity evaluation of the nanomaterials, such as cytotoxicity. The test allows us to gain the toxicity mechanism of action that in the biomat or used for production of innovative. So we perform this test nanoparticles, also with the nanoparticles grafted with polyols and with the nano-enabled compounds, the end products. Also, inhalation toxicity tests or reconstructed tissue of the lung and of the skin are performed. Here there is an example. So the PUR forms can be exposed to artificial sweat or a cell conditioned medium, and then the leachates are collected in order to expose a constructed model of the skin to understand the irritation potential of to evaluate the hazard. And also characterization is coupled when it from this chambers also use the assessment of toxicity assay of specific toxicities of zebrafish in order to understand if a compound nanoparticles can induce a modification in the development of the neural development. So you can use this model to neurotoxicity and last but not least, we also want to evaluate the evaluation of environmental safety. We have a slide on the first site. It's very important. Will be also more important. The fish embryo toxicity test in OECD guidelines our lab, so the nanoparticle are administered to the embryos, and then we are able to analyze after a OECD endpoints such as mortality, malformation, behavior, and so it will be possible to have an ecotoxicity profiles of the nanomaterials and the products that are tested. Our other tests are the Daphne acute mobilization test and the microtox test for the evaluation of environmental safety. So that's it from my side. My main message is that I think that the safety part and such as the sustainability will be very important and a key point in the next year for the evaluation of new innovative products. They are claimed as greener, but I think that was great with our expertise in the Thank you very much. And if you have any question, I'm available.
So, Rosella, thank you very much for your presentation. Unfortunately, even turning off the camera didn't help too much in the connection. We are facing here some issues, and we heard you during the presentation with some cuts, but I believe that the main message have passed. So afterwards, for sure, we will also share your presentation. So if there are any questions, we'll also send it directly to you, and we'll try to manage it, okay? Thank you very much.
Thank you very much.
Thank you very much. So now we still have two more presentations. I would ask Gabby from Globalwise to perform their.
Okay. Yes. We are going to provide a special service to SMEs, including startups. My challenge is always when I'm on stage, already 50% of the audience is asleep. So the first part of the challenge is to help people stay awake. I can understand. When startups or SMEs are taking the challenge of switching to bioproducts, it's a huge step, sometimes requires funding, business planning, etc. So this is our service, and I will elaborate. Globalwise is doing, this is what we normally do in every day. This is our bread and butter. We do business development, startup mentoring, entrepreneurship, helping startups from day one, from idea to become a running business, raise money, and helping them with international market penetration. About the fundraising, it has several goals. First of all, we need to guarantee business stability and growth, reduce financial risk. Naturally, I will not go into the details of every line here. Add strategic partners. I mean, it's not easy to find partners that will help us grow and develop the business. And needless, in our specific case, needless to say, encourage them to participate in the open tender and accelerate their entrance to our world. Fundraising has several stages. The first one, and most, I would say, specific one, is building a pitch deck. A pitch deck is the presentation which we show to the investors or partners. But it's not just a presentation. Presentation is just the face of what's behind. And that's what we call pitch deck or full deck, depends on the version. After we did this, we are mapping the relevant financing market. I mean, there are so many different entities that are candidates for funding, and there are so many types of funding. We need to understand where we're going. That's a lot of energy, especially nowadays when the market is a little bit withdrawing from activities like this. And when we study the opportunities after we have mapped the market. We can connect with potential investors and hit the road. This is, we work mainly with startups, but not only with startups. And it's a real project to find an investor to invest in a company. It has various aspects, professional, managerial, legal, and we have to do it right. Many companies collapse before they manage to get the first euro cent. What's a pitch deck? A pitch deck is made of the following parts, and I will be very brief here because sometimes it's many months' work to produce something like this. First thing, we have to define the need or the problem or the pain. What are we going to solve, or what we need? I'm sure that there are no two SME startups that will have the same definition of what they are going to. And then we will define what the required solution is. Do we need some special market, special product? How do we solve the problem which we have just defined? And then we sketch the company vision. Where do we want to be in a few years' time? What do we want to be when we grow up? Yeah. The next step is very important: analyze the market, understand the market to which we go to. Then we sketch the how to work, the go-to-market strategy, where to go, how to go, and then the business plan, figures, where do we want to be, what is the expected revenue and profit and break even and cost analysis and all these details. So you understand a pitch deck can be sometimes quite heavy. And then we do the company roadmap, which is our plan on what do we do when. The roadmap is actually, you think about a time axis on which different graphs are riding. One is technical roadmap, version 1 of the product, version 2, etc. What features do we add when? The second one is a business roadmap. Where will we be in terms of revenues and profit? And then we have legals like regulation, what standardization do we get, etc. So we have different aspects on this timeline. Now we have ownership of the company. If we want someone to invest in the company, we probably offer him some shares in the company. Thinking about, there are various different formats, different types of investment. But then we have to sketch the entity plan. I will show you a short example. And then our fundraising plan. How much money do we need when, and what do we give for this? So this is there's a lot of know-how involved in such a pitch deck. A few examples just to give you a feeling. The business plan that shows the figures of the company, revenues, cost of sales, gross profit, net profit, so we know how much. This is, of course, a plan. This is a vision. Where do we want to be? We set our targets. I mean, I don't believe that a company can achieve anything without a target. Following this, we can draw a cash flow. We know how much money will we get, or at least we have the estimate on how much money will we get at any time point. So we can, using some normal known formulas, we can sketch our cash flow. How much money will we have at any moment? Naturally, in the beginning, when we are going to a new development of product or system or service, we will be short of money at least in the beginning, in the first few years. That's why we need money. That's why we need fundraising. So we know, you can see in the yellow line below, at the bottom, how much money do we estimate that we will require at any point. So then we can tell our investors, for a company valuation of so much, if you put, let's say, in this specific example, if the company valuation will be 1 million, or let's say here, company valuation 8 million, and you invest $500,000, you will have 6.25%. It's a calculation. Always we're talking in terms of after money, after you put your money, not before. Nobody will invest any money before having this information, and probably he will negotiate. He will be willing to. People can. Company valuation is not something very scientific. It's like selling a house. What is the value of your house? Is as much as the buyer is willing to pay. So, sure, even much worse. Company valuation is more, you're right, more vague than house valuation, because house valuation you have several other houses in a neighborhood, and two companies are never the same. So, but anyway, it's a kind of negotiation. You must offer something and come to an agreement, and then you know how much you invest, etc. Not all investments are for current company valuation, especially in these days. So there are various formulas for investment, such as the one called SAFE, of future value, that one gives the investment now, and the value will be calculated later on, depend on the performance of the company. So this way, both parties are reducing the risk. I will not get into this because it's a little bit more complicated, some more mathematics is involved. But generally, you never invest without an agreement on company valuation and your shares, what you get for it. We have to remember the market of financing is a complex market. When you go to this market, when you want to get money, you have to understand the market. Don't go to, let's say, one type of investor if the chances are low. Try to circle the type of investor where your chances are the highest. This work is professional work of people with experience. There are different types of investors. I will list them here. But just to summarize shortly, the steps are pitch deck, then mapping of the market, study of the options, connect to the potential investors, and hit the road, go talk to them and try to get results. There are different types of investors, as I said. Venture capital companies, normally large investors, companies that are working very organized, and they do study on your company, and then normally for bigger investments. In hard times like these days, they normally invest in companies that have already sales, that have already market. They are not going to early phase. There are few venture capital companies that would invest in early phase, especially nowadays. And then you have something so-called angels. Angels are private people that have something, were lucky to have too much money in their pocket and they want to do something with the money, and not everybody is going to buy a house for it. And people have the idea that investing in entrepreneurship, in high-tech or in development is a kind of a risk that they would take. They are not always experts. Sometimes they work on feelings. Now, there are many. An angel doesn't have a whole battery of experts. That's more VC type. But sometimes you have angel clubs where they use services of legal advisors and financial advisors for a whole angel clubs. It's becoming very popular. And then we have incubators and accelerators. I'm coming from Israel, and in Israel, this is very popular. I mean, every second or third Israeli youngster is willing to be an entrepreneur, open his own startup. And there are so many groups to help them start and run their startup. The difference between an incubator and accelerator, an incubator is normally normally involved. They place their own manager, they put money and take shares, while an accelerator is more voluntarily acting body that helps startups. And many of the large corporates, they have accelerators. At the end of the day, they can pick up the interesting startups, interesting employees. So there are many accelerators and incubators. When you don't know your way, you have a good idea, you should look for one of them in order to accelerate, to start your operation. When you graduate such an accelerator after a few months, you are in a much better position. Then there are all kinds of environmental organizations with funds looking to invest in startups with ideas that would help sustainability and environment. Of course, you have the option to raise money from the public crowdfunding. This is also becoming popular. Then large corporates, as I mentioned, have their impact activities. Large corporates would very much like to be in the front of technology, of good doing for society, and sometimes there are funds available for it. Multinational funds, agreements between countries, national and multinational funds, and even Horizon is an example for it. So these are the options. One must know his way and make a research and analysis of where to go, with whom to talk before raising money. That's what we do. There we help newcomers, small companies, SMEs, startups, and this is what we offer here as well. That's it. Thank you.
So, thank you very much, Gabi. So, as you saw, we are also available to support your companies to get some not only some funding, but also some mentoring in how to grow your business. Of course, using BIOMAT materials and BIOMAT products. So now I will pass the floor to Penina, which will present the work, the service from Bar-Ilan University, which is not able to join us today, but Penina will do their presentation. So just looking for the presentation. Afterwards, we also have one. I mentioned it was only two presentations, but in fact it's three. So we are missing one more from Davinia. You will also, but we'll do it afterwards. Sorry, Davinia, for. So please, if you want to have some.
This is the ahead.
No.
Okay, better. Okay, so as Antonio said, Professor Gedanken is after a very hard heart and open heart surgery, and he didn't come back yet in full power. And Ilana has also some tests, so they couldn't come. I volunteered to do the job for them, and here is the presentation. I mean, they are doing offline characterization of the end products, because inline we have Tavinia, we have CAS that work together, and we will have inline characterization of the processes. Now the end product must be characterized. Without it, we cannot define it a product. And this here we see air permeability determined by the rate of airflow through the known area of the material, filters, clothing, tentage, and sails, parachutes, whatever you want. Testing area is 5 centimeter square, 20, 50, and 100. Standard according to the ISO and ISTM. Next set of tests are flammability tester, which they possess at the Bar-Ilan University. They have, now they open actually an independent unit that will work with the industries that need these tests. And this test is the flammability test. And the fire performance of the polymer, like weight gain, after flame time, after glow time, char length, and things like this. And then they have a vertical plane type of with timer also that can be used for testing flammability. Then they have volatile organic compound testing and analyzing with different devices, VOCs. As you can see here, they can do it with GCMS, they can do it only GC, they can do also only MS, whatever is suitable for the product. Then we have techniques also like HR transmission electron microscopy, HR-TEM, HR-SEM, XRD, Raman spectra, XR photoelectronic spectra, XPS for example, solid state cross, no, I forgot the Fourier transform, FTIR, and then the solid state cross polarization, magnetic angle spinning, CP mass, and then NMR of course, and UV visible spectroscopy, photometer, photoluminescence, elemental analysis, electron paramagnetic resonance, and zeta potential, as well as TGA. All these are available. And I made it short, so thank you very much.
So thank you once again, Nina. Again, any questions, we will forward to Bar-Ilan University responsible for this type of services. Well, now we are reaching the final presentation. Sorry, Davinia. So in that tech, we'll present the service they will provide under the project.
Okay, good day everyone. I have the honor of being the last presentation of the day, so please bear with me for just a few more minutes. My presentation is very short, I promise. So I will be presenting the service from Indatech, which is part of the Chauvin Arnoux group, in this BIOMAT project. Indatech is a company based in the south of France, near Montpellier, which is focalized on the development of spectroscopic techniques. We provide optical solutions for both chemical and physical analyses via non-contact, non-destructive measurements. In our portfolio, we have different spectroscopic techniques such as NIR, UV visible, Raman spectroscopy, and also some specific technologies based on multi-point and multi-angle measurements. These techniques are used in can be applied in a wide range of domains. We're mainly active in the pharma and biotechnology industry, but we also have projects on chemicals and other agricultural or food processes. Everything in the concept of the Industry 4.0. Within the BIOMAT project, the idea is to establish and operate spectroscopic inline sensor concepts for monitoring inline the processes of the upscaled and nano-enabled biopolyurethane products and pilots. In a more concrete manner, we are developing affordable inline spectroscopy-based monitoring systems to provide in situ information of the materials on a molecular level, and the idea is to gain product knowledge and to optimize the processes of the different pilots. For this, in the project, we are only basing ourselves on two types of technology, which are UV visible and NIR spectroscopy. These spectroscopic techniques in general have the advantage of being non-invasive and non-destructive techniques. We can measure very rapidly, so very fast acquisitions, requiring little to no sample preparation and allowing remote measurements from very short to very long distances by the use of fiber optics. The advantage is also that they are compatible with a large variety of matrices, which is important in projects like BIOMAT, where we have many pilots which are quite different. We can obtain multivariate information from the products and the processes to determine, for instance, chemical and physical critical quality attributes, and provide both qualitative and quantitative information and models. Specifically in the BIOMAT project, we are planning to implement spectroscopic sensors in 2 pilots, which are UPC for the quality control of dispersions in aqueous media, and HSK for the product inspection of the foams. But the systems that we are developing are also transferable to the other pilots and can be also be compatible with some of the other procedures that we saw today. So if anyone is interested in testing this type of spectroscopic technology for characterization of their products, well, feel free to contact us. I have indicated our contact information here, so we can go more into detail and function of your needs. Thank you. Sorry? Yes?
So, thank you very much, Davinia. So we are just finishing our long day. We would like to thank you very much for all of you that were together with us hearing these interesting presentations about the project, but also about the different companies that kindly were here today to present their work in the thematic or their advantages or being part of European and national projects together with universities and with research centers. We thank you very much for that. I'm sure that after this meeting you will have the opportunity to continue discussing with the partners that you met here today, not only for BIOMAT but also for other possible collaborations. Hopefully, we would like to evaluate your proposals during the next month. So please feel free to register and to submit your needs, your ideas to the open tender. You have already the register open, and you can find also after the registration some guidelines inside the platform which can guide us to prepare a good proposal. Any questions about the services, about the project, about let's say about what you can test in the project? Just feel free to contact Senti, to contact the contacts you made here today, also to the persons that were strongly attending online this long event. We would like to ask you as well to continue following at least the project and to continue following the opportunities we will have. So we spoke a lot of things today. I think we after the meeting we had yesterday with the consortium, we noticed that there are a lot of topics that we were discussing within the consortium that are also problems from the industry, problems in which we are also trying to find a specific solution, or at least try to help in some way. Decreasing the price, for sure, it's one of the hot topic for the use of these bio-based materials. So, well, I just want to say thank you everyone for being here. Hopefully we will have some collaboration during the upcoming months. So thank you very much. And I think Prina would like also to say something. So again, thank you very much for being here today.